what would be the best interpretation of the confidence interval that was given to us. We attempted and then solved this in class where we said that it is the C, right? That really captures that. Then I gave you this particular example for you to go and try it, where we give you the sample, the margin of error, and the mean of the mean of map per gallons of the data that was given. And the idea over here is for you to construct the confidence interval. And remember, the confidence interval that you are supposed to construct is already given to you. But I just wanted you to construct it so that to see whether you'll be able to get a figure that is the same as that one. So you see this figure over here. That is exactly what you are going to do. So if you are to solve this question, for example, what it means is that, let me see if I can, whiteboard. Can I get whiteboard here? Screen, right? So if I have a whiteboard over here, let me see. So you have what? Um, the formula, right? To actually be just this one, right? So you can pick something like this, and then you use it for the estimate. Now, having this in mind, you know that this is x bar minus what? Now, depending on the question, what is the question saying? The question is having sample size less than 30, right? So ideally, what is the example? Now, why did this thing move to the other side like that? Ideally, what it means is that we are supposed to have, you know, um, a sample size over here, of course, is given to us, which is 70. So it's more than 30. So we can use the Z value as we have been given. So the formula is basically the mean, you know, the mean minus the Z value, right? Z value, alpha, right? Let me see, discard. Let me project the screen. Sorry, I think my presenter mode has dropped. Can you see my screen now?
Yes, Doc.
Yes.
Okay, okay. Um, so which means that just the oh, what's happening to my slides? Okay, I think I've gotten a way out of writing this much faster today, so we are not going to have that hinges. So we have the Z alpha by 2 means that the two tail, right? By 2 times what? Your standard error, right? Then less or equals to the mu, less or equals to the mean plus what? Z alpha divided by 2 into brackets. You have the SE over here, which is the standard error. So you realize that whatever you have over here is given. So this is given to you as this. So you see that figure there, right? Sorry, the sample size. That is the end rather. The n is given to you as the n is given to you as the 74, right? This is n. Then we have the mean value to be this, right? Now, so what you are interested in finding is just the z value. And you know the z value over here is not the calculated value, it's the critical value. Now, we have already been given an alpha value of what? 5%. Means that if you have an alpha value of 5% and you use the standard normal distribution, right? If you use the standard normal distribution, you see that 5% alpha value divided by 2, it means that that's 0. What? 0, 0.05, 0.05, 0.5, right? 0.5 divided by 2. So that will be 0.025. So that 0.025 will be 0.5 minus 0.025. That will give us 0.475. That will be the area to one side. So you just go through to the, your z value table and locate the 0.475. This critical z value that is corresponding to this figure. Then you insert or you come and substitute it in here. Then the next thing is that you calculate your standard error, right? Calculate your standard error. And we know that the standard error is equal to what? Sigma, which is the standard deviation divided by the square root of what? N. Is that not it? The square root of n. That is all you need. So now the next thing that you will need is what? The standard deviation. The standard deviation. But have they given us the standard deviation? No. But the good news over here is that even the standard error has already been calculated here. The standard error has already been calculated over here for you. So all you do is just to do division. It's for you to just do division, right? You just pick the values, plug them into this formula. So you bring the 21 over here, 21.2973 here. Then you bring the z value that you get as a result of the 0.475 here. Then you multiply that with the standard error of 53.07667 here. Then you get your figure. Then that will be in fact, it will be equals to this. So the lower bound will be this, and then the upper bound will be that, right? Remember, if I see negative 344 and negative 133, negative 344 is lower than negative 133, right? Because they are negative values. So the bigger, the lesser, and the smaller, the bigger. Take note of that. So that is how you construct that. And then you just give an interpretation of that, that the estimate or the unknown population parameter will fall within the estimate of minus 344.7008 and minus 133.0879. That is going to be the estimate, right? That is the interpretation of it. So please take note of this. And then another example was given over here, and I explained this one to you last week. Same thing to this one. So please, I think I forgot to put the slides immediately after the class on your page, but I just realized it today and I shared that one with you. But again, if you had wanted to do this, you have the book with you. You also have the video with you, so you could have gotten all of these things from these two materials without necessarily having to wait on the slide. So the slice is just the third option for you to have the same materials. All right. So today we want to move to something different, right? We want to move to something different, how to do hypothesis testing. So that is going to be the main topic for today. The main topic for today. So whenever you hear hypothesis testing, this is not the first time you've heard that, right? When you hear hypothesis testing, what comes to mind? What comes to mind when you hear hypothesis testing, please? What comes to mind? Edward, I don't remember you speaking in this class before. Actually, I've not heard you talk in this class before. Edward Archery. Hmm. Edward Archery has just logged into the system and he's not in class, which is a very good thing. See how people can just lie to us that they came to class. That is good. Who else have not spoken in this class before? Um, almost all of them have spoken before. But Mark,
Sir,
can you tell us
so let me
what comes
try.
to mind?
I put it. This,
My brother, can you reposition yourself better?
Hello, sir.
Because
method. It involves
the
method used to
internet is not.
determine sample data.
Hello,
Sir, can you
sir.
hear me? Hello.
Mark, reposition yourself because we are unable to hear you clearly. Please
Hello,
give
sir.
the chance to somebody to speak whilst you position yourself better.
Hello, sir.
Yeah, who is Edward, right?
Please, I am Edward. I am facing
Mm-hmm.
network challenge. That's why when you were talking, I couldn't talk. I'm very much sorry. I'm there, sir.
So respond to the question rather than saying you are there.
Hello, Doc.
Prove that you are there.
Yes, sir.
Oh, respond to the question doesn't mean that you should laugh at the question. Hey, Edward,
Sir.
respond to the question and then you are laughing at the question.
No, 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 sir.
Ah,
Doc, can I
well,
speak?
who wants to? Okay, Emmanuel or Simon, which of you wanted to interject? And then, okay, Emmanuel.
Yeah, Doc. So it is the method used to make decisions and draw conclusion
Yes, we use it to make
about a population of a sample
about
data, a
a
certain population
population.
of a sample data.
So this population, then what it means is that we don't know the population, isn't it?
Yes, sir.
So if that is it, so what is even hypothesis? Hypothesis, what is it all about? Hypothesis. When somebody say hypothesis or mention the word hypothesis, what is it all about? Simon,
It's the method used to draw conclusion.
no, hypothesis. I'm talking about hypothesis. Simon,
Okay.
hello, hello, Simon, please speak up.
Hello.
Hello, sir.
We are
Please,
required
let's
to
continue
attest
because as the
the
feedback
source
that
of
are
truth.
coming, the feedback that are coming is not going to help us. It will delay us. So please, I'll call you later when the noise come down. So over here we're talking about. Please put off your mics. Over here we're talking about the fact that sometimes we can make claims, right? We can make attributions, we can make comments, we can make factual statements that might be true
Assumption.
or not true about a certain and unknown population. Remember, we already had said that population is difficult to come by, or it's easy to come by, but getting estimate from a population and parameter for that matter is difficult to get out of population because they are very large enough that working with them is quite difficult, right? So
Yeah.
sometimes we get estimate from a sample so that we can make inferences to the the population, and that is what we are going to do over here in hypothesis testing. How can we use that sample information to make inferences into the population? And for us to make those inferences about the population, which might be true or not to be true, we have to make a wide guess. We have to make claims. We have to make tentative statements. We have to make statements that are testable. Those statements that are testable claims that we have made, the process that we go through to be able to ascertain as to whether they are valid or not valid is the hypothesis testing that we are going to do, right? So let's look at what the objective of this particular topic is and then how we can. Of course, just like any other topic, you'd want to look at some basic terminologies so far as the topic is concerned and to look at the different kinds of hypotheses that we can formulate and how we can state them in a certain clear manner, right? And then the different kinds of errors that we are likely to commit whenever we make claims. And when we test those claims, what are the kinds of errors that we commit and how we can avert some of them, and then how we can therefore apply these whole concepts of hypothesis testing to a real life situation for us to make meaning out of situations around us, to make decisions, right? So these are the four major things that you want to look at briefly under hypothesis testing. Again, we are not so new to this some of these terminologies, right? We already are aware of what a population is. And remember, somewhere last semester, last block, I indeed indicate that, population does not only mean animate or living things. Depending on whatever you are studying, population can even mean the number of laptops in a certain area. It can also mean the different brands of laptops that do exist. We can talk about it as the different brands of cars that do exist, right? We can also talk about it in terms of human beings, animals, and things like that, depending on whatever situation you are looking at. So population is basically all those possible values of a certain entity that one is interested in, right? Samples, we have already learned about samples are just a portion or a fraction of a population, whether that fraction of that population is representative or not. So far as it is a subset, it's a subcategory of the population, we call it a sample. Now, what is statistical inferences? Already we know inferences to mean making a certain guess about a bigger picture, right? We are trying to make a certain meaning out of a certain, bigger picture based on certain smaller information and things like that, right? So when we're talking about statistical inferences, we're talking about making a certain generalization from a bigger picture using a sample information. So anytime we try to say that, for example, a cup of water from the lake is good for drinking. Therefore, the whole lake is good for drinking. We are making generalization based on that cup of water we are able to take from that lake. Another example could be that I have fetched water full of a full bucket, or let's say a full tank of water, right? And I decide to pick a cup of that particular water to the lab and test whether that cup of water that I fetched from that tank is safe for drinking. When I test it, whether that cup is accurate, is good for drinking or not, I can now use that result to generalize to all the content of the water that is in that tank, right? So I might be wrong or I might be right. It does not necessarily always mean that when I test the cup of water and it is safe for drinking, it must necessarily be means that the whole tank of water should be safe for drinking. Maybe for whatever reason, the poison is down there, is down inside the tank, so you might not have captured it when you fetch it, or whatever other reasons might. But you are only using that sample information to generalize to the entire tank of water that do exist. So in that case, you see that you are making inferences, and that is statistical enough because you are using just a portion, which is a sample information, to make generalization as to the whole tank of water. So that is statistical inferences. Two forms of statistical inferences that will we would look at, but we have already dealt with one indirectly when we are doing estimation. Remember that estimation when checker cap want to make that decision, it gave us a series of parameters we should be looking out for, and we base on those issues to be able to determine whether he should make that decision or not. That is one. The second part is what we are going to focus on right now, which is hypothesis testing. What is parameter? Parameter, I always tell you that once we have that bigger population, any estimate that we draw from that population is a parameter. That estimate from that population could be the average age of people in that population, could be the number of people who have red hair in that population. For example, the number of brands, different sub brands of that brand in that particular population. It could be, you know, anything, standard deviation of that particular population. This is a parameter. Similar thing to the sample. A statistic is just an estimate from a sample. So if you pick a sample and you calculate the mean of that sample, it tends to be a statistic. It tends to be a statistic. Statistics is the subject itself, right? But statistic is an estimate from a sample. It could be the mean of that sample. It could be the standard deviation of that sample, just like the population standard deviation, right? What is hypothesis? Over here, they gave us a certain definition, but I'll broaden it. That they said it's a statement about a population developed for the purpose of testing, which is very, very good. A statement that is being made about a population so that you'll be able to what, test that particular statement as to whether it is valid or not valid. Now I'll give you a much simplified or a much more intuitive definition of this. Oftentimes that is what I always say, that hypothesis is, so it's a tentative testable what statement, a tentative testable statement about a certain and unknown population. A tentative testable statement about a certain unknown population. Now, it is tentative in the sense that it gives us the room of saying that it can be varied, right? It can be reconstructed and it can be designed or developed at any given time. That is why sometimes you might have stated a certain hypothesis in a certain way, and you find out that that is not the best way to restate to state that hypothesis. So you might have to reconstruct or develop that hypothesis, right? That is one. The It is a tentative, a testable statement in the sense that every claim that you make should be verifiable. It should be possible for us to determine the validity of that statement or not, given the information available, right? So any claim that you will always be making when we are formulating hypotheses, always bear in mind that that claim that we are talking about, it should one be a claim in itself, and that claim should be testable. If you cannot test that claim, then it is not a statistical hypothesis. So a statistical hypothesis in this case would be an assumption that we are making about that particular population. And remember, assumptions can be true or not true, right? Depending on the situations and the conditions under which that assumptions were formulated. So anytime we're talking about assumptions, making an assumption about a certain population parameter, we are putting in conditions that may make a certain claim valid or not valid, depending on those assumptions. So let's say, take for example, that anytime, if I can say that I can make a claim right now that it might rain today, I should be able to verify this claim whether it is true or not. Now, I may give you further information as to why I think that it might rain today or it will rain today. I should be able to give you reasons why I say that. One of the reasons I may say is that every month I have seen over the period of 15 years that anytime we are in the, you know, we are in October, within the first 2 weeks, it does rain. If it does not rain, the third week, Sundays, it usually rain. If I have observed a data on this phenomenon for, let's say, 15 good years, and I'm quite confident that the weather patterns are still being the same and it's not going to fail, I can base on that information and say, oh, hey, today it's going to rain. I will give also another example, and this would really favor our boys so much. Why is it that when you are doing that betting, and I know ladies also does a lot of that, and I will even give their example rather than the guys own. Ladies, are you in the house? I was told that you know how to do aviator betting so much. Why is it that you decide to bet at a specific time and decide to pick a certain odds that, oh, okay, it might flee to 2.0, and when it does flee to 2.0, you decide to cut it there? It's because you have observed a certain pattern of how the plane flies. So you think that whenever it shows these signs, the next possible one would be beyond 2.0, isn't it? This is the reason why anytime you are looking at statistics, you should know that it is a very practical phenomenon. You always use it in our daily life, right? So that is a typical example of what, hypothesis testing, and then the practicality of using some of these things in our daily lives. So that is how we can apply it. So just those claims that we are making, right? Now, having looked at some of these terminology, let's look at the different kinds or types of what hypotheses that we can formulate. Basically, we have two types of hypotheses. Two types. One of the types is a null hypothesis. Remember, we said that the hypotheses are just claims, testable claims that we can always test, right? So if we have to, one is the null hypothesis. What is the null hypothesis? A null hypothesis is usually one denoted as HO, right? It is a statement of what we call the status quo, a statement of no difference, a statement that suggests that there has not been any effect in the situation. The statement or the claim that suggests that the situation is as it is. There's no change. There's not going to be a change. There will never be any change in this phenomenon. If the hypothesis is not rejected, no change has been made, right? Means that the status quo remains. The usual thing exists. The tradition has been maintained. Now, let's give a typical example of a null hypothesis. Which two favorite football teams have met severally and one had always dominated the other? Any two popular football teams that usually meet, but oftentimes one always dominates the other. Can somebody give me an example?
Yes, Doc.
Give me one example.
Man U and Chelsea.
And House of Folk.
Ashanti Kotoko and House of Oak, right? So
Yes, Doc.
if you look at these two popular teams in Ghana, which one has ever dominated in terms of winning compared to the other?
Doc, please, Kotoko.
Yes. If you look at the facts, looking at the number of times they have met before, Kotoko has won more matches than what? Heart of Oak, right? So in that case, if they have scheduled a match between Ashanti Kotoko and Hearts to be played next week, my nine hypothesis that I can say is that Ashanti Kotoko is going to win over what? Heart of Oak. Period. That would have been the basic, because that is the state of school. Because when nothing changes, all things being equal, that is what is going to happen, right? Because data from previous instances has shown to me that Ashanti Kotoko has won, let's say, 15 out of 20 matches that is being played between these two teams, for example, right? So based on that, the status quo or the null hypothesis I'm going to set based on the fact that they will be playing another match next week, I'll say Ashanti Kotoko will win Heart of Oak. As to whether that will be the reality or not will be determined by other several factors, right? Other several factors are those factors will be given to you so that you'll be able to verify this claim, whether the claim is valid or is not valid, whether we should reject that claim or we should not reject that claim. Please, I hope you are getting it. Then we have the other, the another way of stating it, of course, which they normally refer to certain keywords that normally are predominant with this kind of hypothesis, that a statement of no difference in the population, right? All things being equal, or there has not been any change in, there's no difference in, there will not be any effects. Those are the things that is used to what characterize this formulation of a null hypothesis. Now, the second type of hypothesis we want to look at is the alternative hypothesis. Alternative hypothesis, normally denoted as HA, H subscript A. It is one in which some differences or some effect is expected, right? So if the null hypothesis is the hypothesis of the status quo, then the alternative hypothesis is not of the status quo. So if the null hypothesis of the situation between Ashanti Kotoko and Heart of Oak is saying that there will not be any Ashanti Kotoko will not win would win the match. Then the alternative will be that Ashanti Kotoko will not win the match. So it is a counter claim to the null hypothesis. The counter claim to the null hypothesis. So there is always what is being said about a null hypothesis and alternative hypothesis, that a null hypothesis and alternative hypothesis are they are mutually exclusive. Take note of that. Null hypothesis and alternative hypothesis are mutually exclusive, which also means that if the null hypothesis is saying the thing is going to be greater than 4, the alternative will say that it is going to either be equals to 4 or less than 4. Which again shows to the fact that if the alternative is saying left direction, the alternative will say right direction. So there should be a clear cut in the statement of the null and the alternative hypothesis. So if you make such claims about null hypothesis and alternative, and they all seem to point to one direction, then there is a problem with the formulation of your hypothesis. Now, the null hypothesis refers to a specific value of the parameter, population parameter, right? So in the sense that we are saying that it would definitely refer to what the population mean, the population standard deviation, or the profits of a certain population, not of the sample. Now, given these hypotheses, we will look at a very better way of stating them all, right? When we take a typical example. Now, hypothesis testing, as we have already looked at in the terminologies, as the processes we go through to formally conduct or determine whether those claims we've made are valid under certain situations or not valid. We will go through certain steps to be able to, determine that or test this hypothesis. But then we need to know certain key things that comes with it. Just like when you are constructing the confidence interval, you remember that you're supposed to know your critical values, your standard error, your expected mean and things like that, right? So this one too, you needed to know certain things. Now, having said that, this hypothesis testing is just a formal procedure that we go through to either reject or accept a certain statistical hypothesis. But then I'll state something here very clearly. In all this that we are saying, you realize that when we make such claims and we are doing hypothesis testing, we can always result in two possibilities. Either we reject the claim or we fail to reject the claim, right? In otherwise, or in a layman's view, we will say that you either reject the claim or you accept the claim. Is that not it? Which is valid. But in statistical terms, take note of this. In statistical terms, we don't accept a claim. We don't accept a claim. What we rather would do is that we fail to reject a claim. Should I take that again? In statistics, we do two things with the claim. Whenever we test hypothesis, we either reject the claim or we fail to reject the claim, which is also equivalent to saying that we reject a claim or we accept a claim. But because we are dealing with statistical issues such that one cannot with all certainty say that there are enough evidence to reject reject a claim, we always say that when you do not reject the claim, you fail to reject the claim, just to paint the picture that there is no enough evidence against that, rejection. That is why you are saying then you fail to reject. Maybe it will get much clearer when we start doing practical stuff with it. There's also, it's also a decision making process that we always go through. Hypothesis then is also a decision making process that we go through for evaluating the claim that we have made as to whether it's true about the population or not. Some will also refer to hypothesis testing as a significant testing because you want to determine whether the evidence before us, so far as a certain claim is concerned, is enough to determine whether differences actually do exist, and if that differences is substantial, is significant or not. That is why they also refer to it as what? Significant testing. So again, the good news is that it has some few steps to be able to carry on the hypothesis testing. And that process is, my brothers and sisters, if you are able to determine and know the processes of doing hypothesis testing, you are almost done with almost the rest of the things for this semester or this block. Because when we go to chi-square test, we will go through similar steps. When we go to ANOVA, we will go through similar steps. When you want to do, when you do regression analysis and want to determine whether a certain variable is significant or not, you will go through similar procedures. So please and please, this is the foundation of the rest of the things, the inferential statistics that we'll be doing for the rest of the block. So if you don't understand something, please and please let me know, and then clarify certain things for you. Now, let's look at the first step in the hypothesis process. The first step is that when you are being given a scenario, when you are being given a question, you are being given something, the first thing you're supposed to do is to determine or state the hypothesis. Are we okay? We have to first of all state the hypothesis, because we are saying that it's a claim we are making, right? So if we don't state the claim, then what are we testing? So as part of the process to be able to test the hypothesis correctly, we always say that the first step is for you to determine or state the hypothesis or state the claim that you want to what test. You have to state it quite clearly. Now, someone will ask me that what kind of claim should I state? Because we just learned some few minutes ago that there are two types of hypotheses. Should I state the null alone, or I should state the alternative alone? At this step, state both of them, the null and alternative. When you grow and then you know how to work around it anyhow, then and you are looking at it in articles and journals and stuff like that, then probably you might go with an expert view or stating one of them, right? Depending on whatever discipline you are. Of course, there has always been that kind of feeling about some group of researchers that they want you to state but the both hypotheses. Some will always tell you that since the hypotheses are mutually exclusive, there is no need for you to state the two. All you have to do is to state one. The opposite will be true for the other, right? But for the purpose of this class, the first step is to state the hypothesis and state the two hypotheses, the null hypothesis and the what? Alternative hypothesis. Are we clear on that? The next thing is that after we have stated that hypothesis, we do what we formulate an analysis plan, or we formulate a decision rule. That is the second step. We formulate a decision rule. What do we mean by formulating a decision rule? How are we rejecting or failing to reject the null hypothesis? You see that claim we have made that, oh, Ashanti region, Ashanti Kotoko will win Heart of Oak. That would be the Nile hypothesis. Then the alternative would be that Ashanti Kotoko would not win Heart of Oak. It might be draw or it might be what? A lose for them, right? So in that case, he says that Ashanti Kotoko will not win Heart of Oak. That would have been the alternative. Then the second step, which says that we formulate an analysis plan or a decision rule. How is that claim that we just made right now? How are we going to evaluate whether we will reject that claim in the null hypothesis or we will not reject the claim? And take note, anytime we reject the null hypothesis, it means that we have to fail to reject the alternative. Is that not it? If we reject the null hypothesis, means that we must accept the alternative. Is that not it? But remember, I just told you that we don't accept the hypothesis. So if you need to accept the hypothesis, what you do is that you fail to reject it. Does it make sense? Are you confused about that? I need feedback. All right. Other than that, this is just a monologue. All right. The next thing that I want to look at for is what are the key things that we need when we are doing the decision formulation or decision analysis. We have to state whether our calculated test statistic is greater than our critical values. Now, you notice from time and again that we can calculate the z value, isn't it? Or we can trace the z value in the formula. Is that not it? So when we calculate the z value or we calculate the t value, or when we move to the next topic and we calculate the chi-square value, or when we move to the next one, we calculate the S statistic. It is a calculated test statistic, right? When we go to the table, that statistical table, and we trace the z values over there, or we trace the t value over there, that is a critical value. Take note of that. That is a critical value. So you can compare the one you have calculated versus the one that is in the table. If the calculated value is greater than the critical value, then we say that the test is significant. And when the test is significant, the decision we will make is that we usually reject the null hypothesis, which is HO, when that happens. So you see the formula that we have, for example, Z is equals to X bar minus mu, right? All divided by standard error. Is that not it? When we put this formula down and we calculate the Z value, that is called the Z calculated. Sometimes we usually write it like this, Z calculated. Then when you go to the table and you find the Z value, we normally also write it what? Z, we call it Z critical, right? Z critical. So if that calculated value, or which is also called the test statistic, the calculated test statistic, if it is greater than the critical value, which is the critical value here, then we say that the test is significant. Now, this is a typical illustration of what we have. What that means right now. Let's see. We have a whiteboard here. Let me see screen. You notice this, right? You remember we have something like this, isn't it? And we know that these are critical values, right? So all this area over here are this our area for the bounded area with the critical value. So if this place is, let's say, -2 and this place is +2, remember these are the critical values. Critical values. These are the critical values. These are the ones that we have from what? The table. When we read the Z table, or when we read the T table, or when we read the F table, or when we read the what? The chi-square table. Clear? Now, when we calculate the Z value by using this formula, standard error, which is the square root of, and you know that this same thing is the same as S bar minus mu, all divided by standard error. Is that not it? So it means that this whole thing you see over here, this whole thing that you see over here, is just basically telling you that this is the calculated value. So if you calculate or you the Z value, and remember this one, for example, these ones would always, these figures you see over here, the negative 2.0 or negative +2. These ones you read them using the upper value from the table, right? Now, if you calculate this Z value and the calculated value falls somewhere in this region, if it falls within this region or it falls in this region, these are the regions of rejection. And this region is called fail to reject. Fail to reject region. Then the tails you see over here is what? Reject. Reject. This side also is reject. So once you see the calculated value falling inside the rejection region, the the upper and the lower one, this is the lower part, the upper one is here. If we fall in between these, at this outskirts of it, it is rejection, which means that the critical value you see over here is greater than the calculated. Sorry, the calculated one is greater than the critical value. Is that not it? The calculated value is greater than the critical value. Then that means that this condition is met. And so when this condition is met, this condition over here is met, the decision that we have to take is that we should reject the H naught. And we know that H naught is the null hypothesis. So whenever we are rejecting the null hypothesis, it means that the statement over there is true for which we are rejecting it. Means that the alternative, you fail to reject the alternative. I hope you are getting it. When we reject the null hypothesis, means that you fail to reject the alternative. So relating it to the statement of a hypothesis that we stated in the first part, then we say that if the null hypothesis over there is telling us that Kotoko will win Heart of Oak, then we are rejecting that claim and says that and coming to the alternative. And remember, the alternative says that Kotoko will not win Heart of Oak. So means that that is the claim that we are going to settle on, and says that Kotoko will not win Heart of Oak. Now, that is one way of using to do the determination of the decision room. And you must state that clearly when you are doing the hypothesis. The second approach that you can use to determine that is this. When you want to use the the probability value to determine that, which is called the p-value. P-value is a number, right? Calculated from a statistical test that describes how likely are or how likely you are to found a particular set of observations if the null hypothesis were true. So if the p-value, in fact, for you to use this one, you have to always compare your probability value with alpha value to be able to determine that. In using that one, when I give you the p-value, compare that p-value with the alpha value that I'll give you. Remember, for example, the convention is that if I did not give you an alpha value, I told you to use 5%, right? So it means that 5% is also equals to what? 0.05. Is that not it? So it means that if you compare your probability value, which is normally called the p-value, if p-value is less than your alpha value, then again it means that the test is significant. And you remember that whenever the test is significant, what do? We reject H naught. We reject the null hypothesis, isn't it? We reject the null hypothesis and fail to reject the alternative hypothesis. So please, let's take note of that. Have you digested that? Okay.
Yes.
The next one, which is the third approach of determining or stating the decision rule, is whether you use the confidence interval to determine whether to reject the null hypothesis or fail to reject the null hypothesis. Now, I'll show you the confidence interval approach. Look at this. I want to go back to the previous topic and show you something. You see what I have circled here? You see that the confidence interval, the lower bound is what? Negative 344.7008, and the upper value is negative 133.0879, right? Now, if you want to use this approach to determine it, then you must make sure that you must take note of this. If the lower bound is negative, as in this case, you see that the lower bound is negative, and the upper bound too is positive, and it's also negative, then you can say that the test is significant. So you should reject what? HO. That is what it means. So you reject HO. The upper bound and then the lower bound are in the same direction. They are both negative. Or if the upper bound is positive, and the lower bound is also positive, you can still again say that it is significant. But if the lower bound is negative and the upper bound is positive, then it is not significant. So for those of you who would want to use that approach to state your decision rule, it means that after whatever calculation you've done, you have to still go through the calculation of the confidence interval to be able to use it for that, right? So maybe when we take an example, I'll try and see whether we can use all of these approaches to determine our decision rule so that we can know which one is easier for us to use. Take note, for you to use the probability one, they have to necessarily give you the probability value because that is beyond the scope of this class, that we cannot calculate the probability for this one because it goes through a whole process. So the second approach over here, we might not necessarily be using it much. But the last one here and then the first one, we will normally be using this ones. So these are the three approaches that you can use to state your, or you can use to formulate your analysis plan or your decision rule. Now, the third step in the hypothesis testing. So this is the first step. This is the second step. So the third step is after you have determined how you would make a decision out of it, the third step is for you to now analyze the sample data you have. Now, you will now find the value of the test statistic, right? You will find the value of the test statistics using either the z-score or the t-score or the student t-test. They call it the student t-test. Nobody should ask me why did they call it the student t-test. Maybe that would be your assignment to go and look for why did they call it student t-test. So that is the third step. Now, how do we do that? The first criteria is for us to calculate the test statistic. And how do we find the test statistic? Is for us to now apply this formula, right? So over here, let me do this so that it becomes easier because I think there is how it's being arranged over here is not nice enough for you to follow. Let me see if I can place it here. All right. So this is what this it means. Okay. So I think you can see it now clearly. Yes. You calculate the test statistics, and for you to calculate the test statistics is for you to what? Use this formula. Let me see whether my eraser is here. To see whether my eraser is here. Okay. Okay. So you see, this is the test statistic. This is the test statistic. So of course, this is the calculated one or the Z test. And if it is the T1, it is also the same thing, right? Push. My brothers and sisters that are visiting my pointer today, you see that today I'm not having so much issue writing. Standard error. And I already tell you when you can use the T and when you can use the Z, right? You use the Z when your sample size is more than 30, but you use the T when it is less than what? 30. right? You already know this formula as the standard error, which is what? The standard deviation divided by what? The square root of n. So this is how you use to. Then the last step in that third step is for you to now find your critical test statistic using your alpha value, or whether you want to construct the confidence interval to be able to do that, or you have been given the probability value as against the, you know, uh, the probability value as against the alpha value. In fact, when somebody even give you the alpha value and the probability value, then you don't necessarily have to go through even the third step, because you can even make that conclusion direct, right, without necessarily going through the third step. Then you can now draw a conclusion or interpret the results. Then the last step, which is the fourth step in the hypothesis process, is to do the interpretation of the results. After you have done the analysis, you have gathered all these data sets, and then done the analysis, you just interpret the results. You Now, what do you need to do at this stage, the first stage? It is just a restatement of the second step. Let's look at what the second step is. Is when we formulate the decision rule, right? So we restate that in a very different way, so as to go with what we set out to do. Now, what we set out to do is that when our calculated value is greater than the critical value, we said that the test is significant. So over here in this one, we will now compare whether is our z value, z calculated, is the z calculated greater or less than the z critical. Do you get it? If it is greater, then we say that the test is significant, right? The test is significant. That means that we are going back to the first step and reject the null hypothesis. You go to the first step here and reject this null hypothesis of HO. But if it is not the condition and Z calculated is actually less than the Z critical, then we say that we will not reject the null hypothesis. So that is how we do the hypothesis testing. So in terms of its applicability of all what we have just talked about, let's look at this broad classification of hypothesis testing before we dive into the meat of it, right? Now, hypothesis testing, you see that it's a very big something, right? You can use the hypothesis testing to determine an association between two variables. Or you can also use it to determine the differences that do exist between two things. So whether two things are associated with each other or not, you can use the hypothesis testing to do that. Or you would be able to use it to test whether the differences that do exist between them is. So a typical example of using it for testing the difference, of course, maybe when we come over here, for the association over here, we can see whether an event does it correlate with another event that had happened in the past, right? So a typical example is what I was telling you about Ashanti Kotoko and then Heart of Oak. So you are just using it to determine whether there is an association between what has existed and what is. Now, to determine what existed, and you can use it to test whether the mean is associated with a different mean, right? You can also use it to determine whether the proportion of one event is, similar to another or the same as another event. Then when you're looking at using that hypothesis testing to determine the differences between an item, You can use it to determine whether the differences exist in the mean. A typical example is when you are doing uh, conducting a test to determine whether the average wage that is paid females is statistically different from the average age of wages that is paid men. You can use hypothesis testing to be able to determine whether that difference is significant or is not significant. In statistics or in statistical terms, we know that the differences that do exist can be very small, but it might be significant or it might even be big in quantity terms, but it might not be significant, depending on whatever that we are doing, right? So let's take note of some of these things. And when we get to the practical example, we'll take a look at them one after the other. Any question so far? Yes. Mark, have you raised your hand?
Sir. No, sir.
I can see your hand was up. You
It
just
was a
drop it,
mistake.
right?
Yeah.
Okay. Hey, today it looks like there are a lot of people in the classroom, but I know that you are not all in class. My ID has shown twice, so means that 16 of you are in class. 16, but you are more than that.
Everyone is present. Everyone is present and listening. I tend to read as well.
No. How many are you? You are supposed to be 27, right? Cosrep, is it true? You are supposed to be 27, isn't it?
Yes, Doc. Please, you are supposed to be
So, Mark,
27.
why are you lying that everyone is present? Because I cannot see Foster here. Foster. Is Foster here? I cannot also see Joseph or Benji
Doc,
here.
maybe, yeah, maybe
I
because
cannot also see.
these are the regular ones, so he thought maybe that's all of us. But oh, sorry, some are not here yet.
Yeah, I know that. Even Andrews is also not here.
Sir,
Alexander,
sir, me too. My battery is almost going off.
hey, my brother. So, would I also be fair enough to tell you that my battery is also going off?
Oh no, sir. It rained yesterday, so we had lights out, and I couldn't charge. So when the light came, I charged it for the first lesson. Then had just some few minutes before joining you. That's just my problem. I've never done
Is it
this.
not? Is it not phone?
Yes, sir. It's my phone that I'm using, sir.
And so you can plug it whilst you are listening. This one you are not on the call with your ears, right?
Kept earpiece. If not, I can't hear well.
Yeah, you can use the earpiece and be far away from the phone.
Hey.
When you have been calling your girlfriend, is the phone not online and on charge, and you
Oh,
have been
but
speaking all
not to be
midnight?
charging. I've never done that, and I don't have a girlfriend. I have a wife.
No, the time you were dating her before then.
That time there was no mobile phone.
That's are you older than Methuselah?
No, even if there was, I wasn't having one.
Hey,
That's fine. You see how they
assemble.
are laughing at you. You see that people are laughing at you because they know what
Oh,
you are saying is not true. Hmm. Hmm.
I wasn't having one.
That's just by the way. Hmm.
Sir.
So these are some of the broader things that we'll be looking at. So how do we apply some of these things? Let's look at this other difference. In fact, when we are trying to test differences, normally we can have what we call the parametric test, a test with some hypothesis, with assumptions underlining, hypothesis, right? Then when there is no assumptions underlining them, we have the non-parametric ones, right? Of course, we normally also would have the semi-parametric one, whereby certain issues or certain phenomenon comes with certain assumptions and others do not have certain assumptions. So take note of some of these things. We will do it. Now, one of the things that we will do much into details is when we are testing one sample test or we are conducting one sample test, whether it's going to be one sample T test or one sample Z test. Then you do a two sample T test or a sample Z test, where we can talk about the group mean and all that. Right? Take note of this. Now, let's look at a typical example of an independent sample mean test when we are using it for hypothesis testing. So look at this hypothesis that has been stated. Now, I must say, I think when I was explaining, I did not mention it. When you are stating hypothesis, you can state it in two major ways. You can state it as a statement, or you can state it in a mathematical format. All right. You can state it as a statement, as a mere expression that Ashanti Kotoko will win Heart of Oak. Then the alternative would be Ashanti Kotoko will not win Heart of Oak. Or somebody can state it in a mathematical form and say that Ashanti Kotoko would, be, 0, would be equals to 1, means that Ashanti Kotoko will win. Then the alternative would be that Ashanti Kotoko will not be equals to 1, means that Ashanti Kotoko will not win. Do you get it? That is if you refer one as win, and then not to be one to mean either draw or lose, right? So this is a typical example of stating that hypothesis. So in the case of a mean for two independent samples, right? When we are testing the mean of two independent samples, let's take, for example, the average age, the average wage of what? Of females versus the average of what? The average of men or the males. Whenever we are testing that, let's say, for example, the null hypothesis which is being stated over here, it typically says that let's say average age or the average weight of females, given that females is 1 and males are 2, the average age of male is equals to what? The average age of what? Men. Which means that somebody can also state the same thing. This hypothesis, he can also state it this way. HO is such that you see two semicolon, mu 1 minus mu 2 is equals to 0. Please, do you get that? The same null hypothesis can be stated in these two forms. You see that they mean the same thing, right? The mu 1 is equals to mu 2. You can state it as the mu 1 minus mu 2 is equals to 0. Then the alternative, which says that mu 1 is not equals to mu 2, you can also state it as HA is such that mu 1 minus mu 2 is not equals to 0. Please, I hope you get that. So that is what, in fact, it you can state the same things that I've just stated in a statement form, right? In a statement form, that mu1 is not equals to, or is equals to mu2 in the case of null hypothesis. And in the case of an alternative hypothesis, you say that the mu1 is not equals to mu2. It's accepted. Now, the two population are samples, and the mean and the variance is computed based on the samples of a certain size, N1 and N2, right? So in this case, you can see that for each of these samples that were used to produce some of these things, each of them have their own sample sizes, right? So the idea behind this test is similar to the test for a single mean, though the formula for the standard error is different. Means that the formula, the process that we go through when we are dealing with single or the one sample test is different from the two samples test, but the procedure is the same thing. Now, suppose that we want to determine if internet usage is different for males and females. Do you get that? So it means that for any individual, we are mentioning, or we are determining what the internet usage of the individual, but we want to segregate how females use internet as opposed to how men use internet. Will the usage be the same or it will be different? Is it in this class that we had this conversation last time that the when we go online and we saw some items and then we realized that we need a lot of bundles to download those things, the men will run away from downloading them, but females, it's as if when the things are big like that, they want the thing is rather inviting them to download it. They even download it without even knowing that they have downloaded it. So maybe with that kind of idea, somebody might think that, oh, okay, females use more internet than guys. Another thing could be that you might say think that females have more internet products as opposed to men, right? Or men have a certain internet product as compared to men. A typical example is what if I go to the betting industry, I might hypothesize that men use more internet on sporting activities than females. When it goes to social media, I can hypothesize that females use more internet than men. Then I pick data and verify those claims, test those claims whether they are valid or not valid, right? Whether they are valid or they are not valid. Let's look at it also from this angle. We can also look at it from the proportion point of view, the proportion of people, respondents using the internet for shopping, the same for males or females. So you see the item, the same or similar thing. So you can see in this case, we are looking at in terms of relative proportion of men and women or females and males that uses the internet. So this time, while the previous one that we look at, we are looking at the quantity. Do you get it? We wanted to determine the usage, the quantity over here, the magnitude of the difference. Over here, we are interested in the magnitude of differences in the proportion. That is why we are interested in the proportion of the men versus the proportion of females that uses the internet for shopping, right? So in this same, hypothesis, I can also hypothesize again that H naught is such that phi 1 minus phi 2 is equals to 0. Then I also have here H1. So H1 sometimes can be used to refer to what alternative hypothesis. 1 minus 2 is not equal to 0. That is also another way of stating it. Now let's look at something critical, or can we observe something critical about the hypothesis? You can see that the two hypotheses, that it exhibit that property that I spoke to you guys about. The the property of what? Mutual exclusivity. They are mutually exclusive, right? Means that when the null hypothesis is talking about greater than, the alternative is also talking about what? Less than. When the alternative is talking about greater than, the null hypothesis is talking about less than. Do you see the difference? So these are some of the things that we might want to take critical look at, and then be very, very careful when we are stating the null hypothesis and the alternative hypothesis. The test analysis is also similar to the one for the differences in the mean with this one, right? But then with different standard error formula. Remember, the standard error of the proportion is different, right? When that one you multiply the proportions by the end, right? That is the reason why we did all of what we did from the beginning of last block and then the beginning of this block. We went through about how we can the mean of a proportion. The mean of a proportion was when we multiply the proportion by the n. You remember that? And when we take the square root of, is it the proportion by n or so, something like that, and we use it to determine the standard deviation, the standard error, right? So we look at them each again. Now, when we are doing this hypothesis test, one thing that comes very clear with all of this is that we might be making errors when we are making these claims. Look at this. Look at it from this angle. Remember, I gave an example that Kotoko had been winning the matches over the years. Is that not it? So based on that, I'm thinking that the next upcoming one, Kotoko, will win Heart of Oak. Is that not it? But we have all neglected the fact that, let's say, for example, this season, no team has ever beaten Heart of Oak. Maybe no team has ever beaten Heart of Oak out of probably the 10 or 12 matches that they played, which is very, very, very vital to that claim that I've made. So is that claim going to be affected by the fact that Heart of Oak is really, really untouchable this season, for which I must refine that that claim, or I shouldn't refine that claim? It's very important, right? What also about the fact that if the referee were to be the one who have been deciding those matches, not necessarily because Kotoko is very good and in beating Heart of Oak. So whatever I'm trying to avert your mind to is the fact that genuinely Kotoko might be good, better than Heart of Oak. Coincidentally, also, Heart might be better than Kotoko, but because some other factors have been preventing Heart of Oak from winning Kotoko, that is the reason why we often see that the matches always ended with Kotoko most of the time winning Heart of Oak. So it again tells us that the two sides of the coin can place over here, right? Whether the right person is diagnosed properly or the wrong person is diagnosed rightly. I don't know whether you get it too. I'll repeat it again. Whether the right person is diagnosed wrongly or the wrong person is diagnosed rightly. There are two kinds of issues that we're talking about in the That will bring us to these particular kinds of errors that we are likely to commit whenever we are dealing with hypothesis testing. Now, let's look at the first one. The first one, we are saying that um, we are talking about the fact that a type 1 error, whereby we say that it occurs if the null hypothesis is rejected when it is in fact true. Let's pause over there and ask ourselves, when is a hypothesis, when we reject a null hypothesis? We only reject the null hypothesis when the hypothesis is false, right? So we reject it. But when the thing is indeed true and we reject it, what does it mean? It means that we are committing an error. It simply will mean that, for example, the person is a criminal and we have not found any evidence that he's a criminal. So we leave him on the streets. Do you get it? It's usually happen in our societies. Then in that case, we are saying that that is actually the probability of what? The significance level, because of how your alpha is being constructed. That is why that error is occurring. So you can see that the situation exists, right? But it is being manipulated by the evidence that is around it. So if we say, for example, our p-value, when we want to use this for hypothesis testing, and we say that if p-value is less than alpha value, we should reject H naught. Is that not it? And you know that this alpha value is taken arbitrary. If you use 5%, it might be very difficult for you to reject it. So somebody might comfortably go and use 10% to reject it. When that happens, you are committing what we call a type 1 error. Then we have another type of error, which is type 2 error. It occurs when the null hypothesis is not rejected, when it is indeed false. In that case, a typical example we can give to that is that a criminal that we do not have enough evidence to prosecute. So comparing it with the type 1 error is that the guy is not a criminal, but you have seen some evidence that suggests that he's a criminal, so you jail him. Type 2 error is that the guy is indeed a criminal, but you did not have enough evidence to prosecute them. How serious is each of these things? Let's give it a real life situation. Let's say that there is this hunter. He's a hunter, right? Or let's say, for example, you go to the bush and then you found or you are going to get some mangoes for yourself. Sorry, somebody's mic is on. Can you off it, please? Let's say, for example, mango season, you decide to go to the mango tree to go and get some mango, right? When you got there, you saw a dead body there in the bush. You saw a dead body. So you ran home to go and call police people that somebody is dead under the tree. It looks like the person has been shot dead under the tree. So you came to call the police people. So when the police went to the bush to look at the scene, coincidentally, when they got there, they saw a hunter with his gun. What do you think will happen to that hunter?
They are still him on shooting the man.
They might say that he's the one that killed the person. Maybe because even if you see the dead body too, it's a gunshot that killed him. So you are likely to say that he's the one that killed him. In fact, there is no way you can defend yourself that you are not the person, the one who killed him, isn't it? Because every evidence suggests, coincidentally shows that you are the one. Such a case, you see that an innocent person with the wrong evidence we are going to jail that person that he is the one who killed the person. Type 1 error in that case. You are going to jail an innocent person for the wrong reason. He has not committed a crime, but you are jailing him. Another issue is that you might find out in the situation that, oh, the guy is the one that committed crime, but he had money, so he got good lawyers to defend his case for him, such that any evidence you prove against him, he's able to defend that the guy is not the culprit, when indeed he is the one who committed the crime. So the judge might end up saying that, oh, okay, the evidence against this man is not enough to prove the case that he's the one who committed the crime. Therefore, the guy should go scot-free. What it means is that you are leaving a criminal to live on the street. Is that not it? Because you don't have enough evidence to jail that person. That is a type 2 error. So there's always a question that I often will ask. Maybe you may want to take note of this. And I would always ask you, of these two types of errors, which one is more severe? Type 1 error or type 2 error? Give an example to support your your discussion. Is it to jail an innocent person, or is to set free a criminal? Can I hear some thoughts whilst I
Hello,
catch
Doc.
my breath?
Hello, Doc.
Just
Hello,
Who is
sir.
starting? Okay, I can see that
Please,
the ladies want to take the floor. Ellen and then Fosti. Who is coming first?
Hello, Doc. I'll continue.
all right,
Ellen
thanks.
starting.
Okay, please, I'll say type 2. In this case, the criminal is left in the society. So he may
So
commit
another
another
crime, right?
crime. Yes.
But if it happens to you that you are the innocent person and you have been jailed, that is when you see how
Always
prayer
the
works.
truth will come out. So
Who
I
says
believe
so that always the truth will come out? Are some people not in prison right now for the wrong reason, and they have always been punished because they have not done anything, and your life has been destroyed for life? You have been jailed for life imprisonment because they saw you at the scene that with a gun, so they jailed you for life. No amount of words can change it. You are in the
yes.
prison. You are saying that one is not severe compared to if we leave a criminal to be on the streets. Ellen, that's what you are saying.
Yes.
Well, that is your perspective. That's fine. Who else wants to share his or her perspective?
All right, Doc. Mine is
Mm-hmm.
both are
You said?
severe. In the sense that I said both are severe cases. In the sense that the type
Both
one
are
error,
severe.
yeah, the type one error, the one who has been killed, one, they are they are feeling his right, his right of moving
Yeah.
about and whatever. But it's one, it's against his rights and against the force of labor in the country to be, and therefore production itself, will not increase as we want. Therefore, it will
No,
affect our
it looks
economy.
like it looks like. Can you please repeat your explanation again, because I keep losing you kind of.
Okay. Both are severe cases in the sense
Mm-hmm.
that the first error, the one who has been jailed, one, his right has been infringed upon. And
Yes.
secondly, the force of labor too has dropped. Because if he would have been outside,
The
he would have
what has dropped?
labor force.
The what has dropped? I'm not getting that side clear.
Labor force.
Labor force.
Yes. For him to
That is
work for
if he is
production,
within the age limit.
yes, if only he's within the age limit, it will
Yes.
affect our labor force. And therefore production will
Mm-hmm.
decrease, which will definitely
Mm-hmm.
affect our economy. And
Mm-hmm.
the other one to the side too, after my sister said already, this guy is left in the society and he can still go on to commit more murder, which will
But
still
that one to
affect our.
productivity can increase because he is going to be part of the productive,
The one house guys.
yeah.
Doc, no. How can he be useful in the society? This guy is not doing anything useful to support the society.
Because,
Please.
no,
He's rather,
I'm just on the same point. I'm just on the same point you raised earlier on that if the innocent is jailed, which means that we have reduced productivity because the person who is part of probably that labor force has been jailed, so his life has been curtailed. But the one that you also be the criminal and they leave you on the street, we should have jailed you to reduce the productivity, but we have kept you on. But yes, I understand your point that he might have killed, he would have gone around again killing extra people. So again, that would have reduced the productivity.
Mhm.
Is that your point?
Yes, Doc.
Mm-hmm.
Uh-huh.
Any more
So,
diverse view?
all right, so Doc. And this guy
Mm-hmm.
too, in fact, aside reducing productivity, he is a threat to the society. In fact, it will scare most of the people, even within the society, to, or it will not even allow, if he becomes a notorious guy, he will even
Yeah.
hurt more investors not to even to come to the society or the country that we are in to help in our economy to grow. So I think such a person should not be left to be mingling
I mean,
or to be part of the society.
it's not
That's
that
my,
such people should not. It's not that such people should not be made to mingle with people in society. The whole idea is that you are testing a certain hypothesis, whether he's a criminal or he's not a criminal. Each of the two examples, we are testing the innocent, whether he's the one who did the thing or not. The second guy who is a criminal, we are testing whether the evidence before it's substantial that he's the one that committed it or not, right? In the first case, because of the coincidence, that the evidence that coincident with when the police people visited the mango tree, coincidentally he was holding a gun, he was in the bush, and probably he was even trying to help the man to see whether because whether he's dead, indeed dead or not, and they just arrived on him. In fact, no amount of words can even explain you that you are not the one who killed the person. So that is that the evidence that supports that innocent person cannot take him out. Means that the evidence is so huge that it cannot erode that genuineness in helping the case rather than he being a culprit. The second case, he's the culprit. However, the lawyer he has, the lawyer is able to give him enough justification and trying to prove beyond doubt that even though those things can exist, he is still not the person. So you can see that you have the evidence, but the judge is not having enough evidence, or the evidence is not enough for him to stand on and jail the person. And in fact, in these two type of errors that we've just discussed, none of them is preferred over the other. None of them is really, superior or is better for us to substitute for the other necessarily, because they all have their own consequences. Have you forgotten the fact that if that man, that innocent person, is the breadwinner of a whole society, a whole community, you look at the number of people that are going to be in trouble. Do you get that? If we did not avert our minds to that, right? It's also going to cause huge implications. Just like how if we leave the criminal, he can, kill more people, he can make a whole society suffer and all that. The same way, if we leave remember, some people even, let's say, for example, some people even commit crimes because they have been accused wrongly before. So they are now angry with society, isn't it? A typical example, in the village that I grew in, there was a situation. Maybe I need not to say this one on air, so I'll keep that example. I'll not say this example. You see that the guy has not committed any crime, but they force it down his throat. A typical example is myself. Yes, I remember those days. Yes, those days we used to go to a certain farm, right? On that material time, there was one time that somebody came to complain to. They have a, how do you call it? This cashew tree, cashew. You see the fruit, eh? People have been stealing it from the man's farm. And we also go to farm around the area, so we usually pass that route. It's a major route anyway, so a lot of people pass through that place to farm. There was one time, and somebody go and tell the farmer that it is we that have been coming to steal the thing, me and then my siblings. And he even tell the person that, in fact, he even tell the person that he saw us coming to the farm to steal. But you know the funny thing about the whole thing? That very day that he said he saw us, none of us even went to farm. We went to school. It's a school day on a hot Tuesday. So it turned out to be that it is not true because we don't even go to farm. We, the kids, we don't go to farm on Monday, Tuesday, Wednesday, Thursday, Friday. We only go to farm on Saturday and sometimes Sunday. So whatever the person was saying is blatantly false. However, look at the implication of us. Because of that lie, my father was angry and tell us that we should not pass through that route again. So we have to use an alternative route. And alternative route is far, far, far than that route that we usually use. So you see the implication on us, innocent as we are, because of that force, it has really caused some others to what? Suffer for it. So these are some of the things that, of course, it helps us. So anytime we are making decisions, we are very careful which one we are making so that we make the right decision. Let's look at the balance. So you see what I have stated at the down here. We says what? It is necessary to balance the two types of errors so that you don't hurt anybody or you don't hurt any society or stuff like that because they all have their respective implications. So if you make these decisions, so this is one decision you can make, this another decision you can make. Now, if you reject HO or you fail to reject HO, what if HO is true and HO is false? So you realize that anytime you reject HO, but HO is actually true, it leads to what? It leads to type 1 error. So in the sense that you are, for example, in that case, in this particular case, it means that you are rejecting a criminal when indeed he is a criminal. You are leaving a criminal to be on the street when indeed he is a criminal. So it's like you are rejecting that he is not a criminal, but innately he is a criminal. But if you were to reject him when it is a false, it means that you are making a correct decision such that you are rejecting his bad behavior, that kind of thing, right? So in that case, you would have made a right decision. If you fail to reject the hypothesis when it is indeed true. Remember, that is the hypothesis of status quo, that the person is a free person. And if indeed you reject him and he is a free person, then you have made the right decision. However, if you have rejected and it is a false one, and he is not an innocent person, but you end up rejecting it, then you are committing what? A type 2 error. So you can see that in each of these ones, we must be measured. So this is one of the biggest reasons, because of this danger of committing type 1 error, type 2 error, the implication of it. That is why oftentimes we always have or we always say that you either reject something or you fail to reject the thing. Have you seen it? So you either reject each note or you fail to reject each note. When you fail to reject the thing, what you say that you don't have enough evidence against it. That is why you fail to reject it. I hope you get that. You don't have enough evidence against it. That is why you are failing to reject it. But if you had enough evidence against it, why not? That way you would have been making the correct decision. Now, when you are making these decisions, the probability that you make the right decision is what we normally would call the power of a test or the power of a hypothesis. So a power of a test is just the probability of rejecting the null hypothesis when it is false. And when you reject a null hypothesis that it is false, look at what is here. Rejecting a false null hypothesis. Rejecting a false null hypothesis. You see that that is the correct decision you have made. Have you seen that? And when you fail to reject a null hypothesis that is false, that is true, that would have been the another power of a test, right? So the probability that you are making the right decision in a nutshell is what we call the power of a test. It is normally looked at as what 1 minus b. Beta is 1 minus alpha. Sorry, uh, 1 minus alpha is actually beta, right? So 1 minus beta is definitely the alpha. So it is dependent on the alpha value that help us to determine the power of the test, right? Now, the probability of making the right decision about the null hypothesis is what we are talking about here. The probability that you are making the right decision is what we are considering over here. Now, it also means that it is the probability of we not committing the type 2 error. So the probability that we are not committing the type 2 error is called the power of the test. So you can see that we can have so many meanings to this. The probability of not committing type 2 error is the power of the test. The probability of rejecting a false null hypothesis is the power of a test, right? Take note that beta is not new, right? But we also know that it is related to alpha. An extremely low value of alpha will mean that the result is intolerably what? High beta errors, which means that anytime your alpha value is very, very, very small, it means that you are increasing the level of precision, means that you are setting double standard. That is the reason why you see that at a point in time, you would have been leaving a criminal to go scot-free. So I would explain it also in this way, and it becomes very easier here. Look at this. If we want to determine whether somebody does something wrong or not wrong before we ask the judge to, pass judgment on the person, if we have set the criteria for determining that so high enough, it means that we might find out that at the end of the day, nobody would have met that criteria. But the person might be culprit. Do you get it? That case, it means that we are committing type 1 error such that we are increasing the threshold to determining somebody to be a criminal too high enough that we might not get the facts to support it. That way we are committing a type 1 error. But if we are also losing the threshold too much, means that with any little thing, we can say that, oh, you have met the criteria. That way, we might also be pushing what? An innocent person to jail. So do you get it? So you can see that the type 1 and the type 2 errors, they are not necessarily left and right something. They are all on the same direction. But depending on the extent of the criteria we set, that would make it what? A type 1 error or a type 2 error. And that feeds into what the power of the test is, the probability that we are making the right decision. I hope we all get that. Now, if you are able to get that, the next thing that we want to look at for is the effect size. The effect size is normally what we call, when we are doing the, how do you call it, sampling distribution. You remember that the differences between the mean and then the sample mean and the population mean is what we call the sampling error, right? It is similar over here. Effect size is almost the same or synonymous to that one. However, the sampling error is related to what? The distribution of the sample. But this particular one is the difference between the true value and the hypothesized value. The claim that you are making, the difference between what you are claiming to be and what it actually is. By in the sampling error, we're looking at what the population has minus what the sample has. But the effect size is looking at what the population has and what's the claim you are making. Please, I hope you get the difference. So you can see that the hypothesized value could be, so let's say the true value could be the mean, and the hypothesized value could also be another mean. So I can call this one, for example, hypothesized H, and this is the true mean, something like that. So it's basically the same as that of what? The sampling error. Now, there are different ways of calculating this effect size. Remember, the difference between the true value and the hypothesized value is the effect size. Now, there are different ways of calculating it, right? Now, what is the standard definition of effect size? It's just a statistical concept that helps us to measure the strength of the relationship between what? Two variables on a numerical scale. It's usually measured in 3 different ways. One of the ways is when we look at the standard difference, standardized mean difference. Another way is when we use the odds ratio. And the third one is when we use the correlation coefficient. Now, for the correlation coefficient, I will not treat that one here. When we go to the last topic, which is correlations and correlation and regression analysis, then we'll do the third one over there. The odd ratio also, when we are doing regression analysis and we do something like other type of regression analysis, which we will not definitely do, we would have addressed that one. But we would only deal with this particular one, but take note of them. This is a very beautiful objective test question. Which of the following is not a measure or is not a criteria we use to measure the effect size? Then you see the standardized mean difference there. You have the odds ratio there. You have the correlation coefficient. And I can add the third one, that regression analysis. Then you choose between them, right? So in that case, you see that regression analysis is not the one for the effect size, right? Then also, of course, maybe to some extent, you can even use the regression analysis, but in this case, you can see that that is the odd one. Now, the standardized mean difference is used when a research study is based on the population mean and the standard deviation. So whenever you use the population and then the standard deviation one, then this method can be used. The effect size is basically the mu minus the mu1 minus the mu2 divided by standard deviation. So you can see that the only difference is that if this is z square, this is z statistics, it would have been what? Z minus 2 divided by sigma. This sigma over here divided by the root of n. But you see that this one is not divided by root of n. That's the only difference between that. You see this? The only difference between that is just the denominator here. You see the denominator here, which is the root of what? N. The root of n, which is there. Then also that is the standard mean difference formula. The standard mean difference formula. There's also another one we call the coherence D effect size. The coherence D effect size. The coherence D is also known as the difference of two population mean. So when we have the two population mean and it is divided by the standard deviation from the data, we call it the coherence D effect size. So the formula for the coherence D, if it is from a sample, then this would have been the case, right? Of course, this is how the formula is. So you are saying that the mean of the first sample minus the mean of the second sample divided by the standard deviation and divided by the standard deviation. And you know the standard deviation, which is the bottom one, is equals to this. So this is the combined standard deviation of two samples. When you want to put the standard deviation of two samples together, this is the formula to use. So the coherence D itself is just to look at the difference between the sample mean, the first sample mean, and then the second sample mean, divided by the total or the sum of the standard deviation. And the sum of the standard deviation is given as the square root of all this. Remember, if we are to be looking at the standard deviation of 1, you would have been looking at summation of what? S minus S bar all square divided by n square root of it. Or for example, is this not what we have? This is what we have in terms of if it is only one sample. But if it is two sample, you can see that that is when the denominator, we add the denominator. So let me see. We add the denominator, the 1, and then, so this is 1. So we just add the denominator, and then the numerator also we add another one. So you can see what we have here. So if it were to be for one sample, this is what we have. Another sample, this is what we have. And because the n are 2, so we add them to the, so there's no much difference between this. Now, what are the factors that influence this power of a test? The probability that you are making the right decision. What are the factors that influence it? 3 main factors affect it. One is that the sample size. If your sample size is so small enough, variations might exist, and that might tend to cripple your decision-making process, right? It might not help you to get the true estimate that you are interested in. The second one is the significance level, which is also called what? The alpha value. You realize that if the alpha value is too small, for example, if the alpha value is, let's say, 5%, you might be rejecting the standard stuff, right? If you raise the bar to 1%, it means that you might extremely, or you might make the standard so hard for somebody to fall within just 1% to be considered as a criminal, right? As also opposed to if you say that, okay, the standard should rather be 0.5%, which means that you are making it extremely, extremely difficult for someone to be able to determine whether somebody is a criminal or not a criminal, right? You might have to determine those, and it will be very difficult. So if you raise the bar too much, let's say, for example, another example, let's look at it from the criteria point of view. Please, can you put off your mic if you are not on the floor? Let's say, for example, for you to get an A is what? For you to get 3.6 and above. Is that not it? That is when you can get first class. Is that not it? That is the standard, right? It means that if we decide to now send the criteria to what? 3.8 right now. How many people do we think can get the 3.8 and will get the first class? Very, very few people. And it might even be much more difficult if we now move the criteria to 3.9. Do you get it? So it's making it difficult. The more we increase that criteria, it means that one, it is good in the sense that we are getting the best of the best. That for you to now be called a first class, that means you really merit it. Means that you have gotten somewhere 3.99 something before you can get the first class. But if we decide to bring the criteria to 3.0, you can see that 3.0 to 4.0, a lot of people can fall in between. So again, anybody at all can easily get what? Anybody at all can easily get the first class, right? And when anybody at all can get the first class, it will now become difficult for us to now make a determination as to who really qualify as the best brilliant person that probably we are looking for which we instituted that measure of determining those. Do you get it? So it means that we have to always balance that criteria that we have set for ourselves to determine the best students versus not to cripple those who are very good but did not make that mark, and those who are not also good but have made that similar mark. So the significant level is also very key in determining the power of a test. So the power of a test will be very, very small if the alpha value is very, very, very small. That way it is extremely, means that for one to fall within that category, that means the person really, really, there is more than enough evidence to have proven that. Then also we have the true value of the parameter being tested. When the true value of the parameter being tested itself are large enough, the deviations might also cause that the significance of a test might be evident or might be easily evidential when we are looking at that, right? Might also be very, very easy for us to look at it. So these are some of the three main factors that really help us to determine the power of a test, right? To determine the power of a test, right? Any question as to this stage now? Because we are supposed to finish this topic today and probably start another one. But if you're able to finish this one today, then that is good so that we would have used two meetings for 3 topics. That is what we are supposed to do. Because the other topics that are there, they are stubborn, right? We may not be able to get there. Any question up to this stage? If you don't ask question, I'll ask you question. Okay. Can I ask my question? Since nobody is ready to. Hmm? Can I ask my question? Yes, Doc. Let's continue. So we have gotten to a stage that we want to apply some of these concepts, right, into our daily lives and whatever we have been doing, right? So we can always apply them to whatever we are doing. We can always apply them, right? So some of the applications, we will take them in the form of questions and then see how best we can make use of them, make use of it, and then make meaning out of the society that we are in, right? So let's look at the first example. These are questions about what we have learned. So from now going there, we are only going to solve questions and then with this particular topic, right? So can you answer these questions? I told you to answer ask questions. You did not. So what's the name? Douglas. Sorry, Douglas. I can see you as the first person here. Is he gone? He's still there. Yeah. Emisa, I've not remembered seeing this face in class before or this name in class before. Douglas, have you just represented by logging or you are representing by listening?
No, I'm wrong. That just network gave me a problem.
This hmm, the day that God will expose all of us with this network issue. Don't worry. Once you are able to hear the question, that means the network is not a problem. So please answer my question.
Hello.
Hello.
No doctor. It's my side.
I think he's having a network issue.
Come again.
I think that has left you.
The class has ended. Or
It has not. I think that has left.
We usually have network challenges like some of us.
That's okay.
Yes.
Hey, no, no, I've been logged out, kind of. Hey, this was there. My enemies are against me.
Douglas affected you.
No, no, I can't.
Douglas affected you.
No, people have really gone to the shrines to do something just so that they can have something to say. That I say, you see, if you have encountered it, no problem. Douglas, it does not erode the fact that you are on this one. So we are waiting for Douglas.
Yeah, please, I want to answer the first one for Mr. Douglas.
Then okay, that means your own will come in a different way. Hmm? Okay. So
Okay,
so you want to
it's like,
respond to that one for Douglas?
yes, please.
Okay, please then go ahead.
And Doc is type 1 error. Why? Because we directly set the significant level, that's the alpha, which is uh, the probability of rejection a true null hypothesis.
For what?
So
For what?
I said it's because it directly sets the significant level, which is probability of rejecting a true null hypothesis. So I
Hypothesis.
think it's
Mm-hmm. Who has another view and can give me a very compelling one as to which of the errors can we have control over?
But I think it's type 1 because type 1 is a probability of rejecting a null hypothesis when it's actually true.
Mm-hmm. Uh, who else has a different view? Who has a different view of this? So we said that with the type 1, because we can adjust the alpha value, right? It's arbitrarily taken. So it means that we might have committed the type 1 error if we use 5% alpha value versus when we use probably 1% alpha value, right? So what is the justification for we using the 5%, 1% and not the 5%? And why the 5% and not 10%? These are arbitrary taken, so that could influence that, right? That could influence that. So which kind of hypothesis error is committed when we decide to retain the null hypothesis? If it is, I did not complete this sentence. I don't think logically it makes sense, right? Uh, Yes, it's well false. So uh, error associated with the decision to. So in that case, we might be looking at so can somebody respond to this one? Sorry. Menu, Simon. I've been calling Simon too much. Simon, just relax your breath. Let me call somebody else. That doesn't mean that I've been calling you too much. This guy, I've not heard his voice today. Pagachugi. What's the name? Maybe you guys know how to pronounce it better than I can. Paga,
Yes, Doc.
Paga,
Yes,
please.
Doc. Can you hear
Second
me?
question. I can hear you loud and clear.
Okay, so I responded, but let me also answer like you're asking. So to me, I think the second question is type 2 error because you have to make a decision as to whether to retain the null hypothesis
That's against the alternative.
when it's actually false.
The third question. So if this one is type 1, type 2, this one will be type 3, right? Let's move to the fourth question. Who is responding to the fourth question for me? Let me see if I can get some name that is not common. Who have not been talking. Williams. Williams.
Sir,
Eric, just hold on it. Let William come and then let's hear his voice before. Take the fourth one for us.
it says which two decisions, which two correct decisions can the researcher make? So please, a minute.
Why a minute?
So I got lost along the line and I came back. So
No,
there
you
are
are
some
listening
parts
to
that
us. You are listening to us. No, and even if we give you that time, what are you going to do? I know what you wanted to do, but I will not say it. Don't
I
do
wanted
that.
to go back to
You
the.
have to test. You have to test your mind now. You can't go back because you don't have the slide exactly to go, unless you want to go and refer to a book or a different resource material. Other than that, train your mind to understand it now rather than referring to something. Call somebody to bail you out.
Uh, um, Ellen, I beg, help me. I'm stuck here.
Hmm. The thing is on Ellen. Ellen,
Yes.
over to you. If it is money right now, you will not call us. Why did they mention your name?
Hey, really?
It's Ellen Boamina.
Unaware, right?
Firstly, please do ask the Anna, please.
Hey.
Hello, dog.
Mm-hmm.
Please. Mine is
Hmm?
the two correct decisions that a researcher can make. I think the first decision that a researcher can make um, is correctly retaining a true now hypothesis. And then the second one is
Correctly
to
what?
correctly retain a true now hypothesis.
If you retain a true null hypothesis,
And that is where the null hypothesis is true. And therefore, we need to include the so that we have no effect. Then the second
What
one
are
is
the two?
correctly with
Mm-hmm.
the
Correctly
first one
rejecting
is
what?
correctly two null hypothesis, and the second one is correctly reject a false null hypothesis. It's either
Can
to
somebody also?
retain okay
Mhm.
and to reject
What-
a false null hypothesis.
Can somebody clearly state what she's trying to say?
Sir.
The people who took her as a lawyer,
Okay. Please, I'm not the one
those
to
who
as a
took
lawyer.
her as a lawyer.
Mr. Mark, be careful.
Hello, Doc.
Ellen, you took her as a lawyer. Are you the only two ladies in the class?
No, Florence is here.
Hey, then pass the thing to Florence rather than you saying it again. Pass it to Florence. That means, apart from Florence, you don't have any lady again, right?
Yes, we are three.
Making three. Oh, okay. Florence, the two ladies have spoken.
It has Belas. Florence.
Florence is not on call with you guys.
I'm on
That
call,
means
please. I am.
you know that attendance was to affect you, so you come back.
No,
Okay,
I'm on call.
no problem. Build them. That is the bone of contention.
See, you see, Tina is even laughing at me. But today, Doc, I think Pius is not with us today.
Please, the question is not Pius is with us or not with us.
Hello.
We asked a simple question. Florence, why are you going back to checking attendance when the question is not about attendance?
Hello.
Answer the question for us. But you see how Ellen is laughing at you after selecting Florence, and Florence also imposing it on me. Okay, you don't worry.
Uh,
Pick
Doc,
anybody who you think has not spoken today.
Doc,
Okay,
yes,
every
my
point to
brother
mute you guys up.
Nkrumah Samoa and
Doc,
Pius.
yeah, I
Okay,
was having a challenge on my distance. Now they are okay.
Hi.
don't worry, don't worry. We will not give it to you now. I know why. You will hold on. We will give you a different question later time. Um,
But
I
Doc,
know
I
why.
thought you said you are discussing the whole question.
Yes, don't worry. Say there are extra ones. There are more than this is just example one. Oh. There are six questions in example one. So we
Okay.
have another ones there. Uh, Joseph Obi. Joseph is the single guy. Eh? Is it the Joseph that you guys pointed that is single?
Yes, please.
Uh-huh. For him, there I know that he has a lot of time. Then he can learn. Joseph,
Yes, boss.
can you bill us?
Dog.
Mm-hmm.
Yeah, I can hear you loud and clear.
Yes. They say you don't have a child, so you have all the time to learn. So bill us.
Oh, that is not true. That is not true. It's true that I don't have a wife, but I'm not married. But I'm busy most of the times.
So are you saying that you also cannot answer the question?
Please,
This one.
which of the question are you answering?
Joseph,
Which one?
please.
Hey, that means he's not with us. This one.
I was following it. Just that I went to do one or two things, and so when I came, okay,
No problem. No problem.
question four.
Question four.
State the two correct decisions. Okay. If I heard it in the course of discussion, I know you have now retain it. You have to make sure it's true. Then what I know is when it is
I beg you, I beg you. Certain
false.
things,
When you
if you don't
explain
have the idea, please, it's best for
Okay, Doc, can I come in?
the nana how
you. Hold on.
My phone is
Can,
worrying me. That is why I wanted to talk. My phone is worrying me.
hello dog.
when phone is now worrying people, they want to talk. Don't worry, your question will come.
Hello.
Okay, no
I know
problem.
what
My
it means.
phone is back
I
on.
know what it means to. I know what it means to volunteer yourself to speak.
Hello. Dog, can I mute
So you,
myself?
yes, Joseph, you can mute yourself because, but what the answer you are trying to give is more suicidal because
Oh, but
no, you see,
what you explained to
I
me,
gave you
what
when we are looking
you
at.
said something about now hypothesis. Is that not the case? That when you retain it,
Yes, we said
you make sure it is true.
no,
Is that
please.
okay?
I did not say you make sure it is true.
Oh,
Please and
okay.
please. You will not make sure something is true or false. It is
Oh,
the
okay.
evidence before you that will make whether that evidence you have is sufficient enough to make a decision for the null or
Oh,
against the null.
okay. Okay.
So
Okay.
when this question is asked that state the two correct decisions that a researcher can make, it's so simple. When we are doing the
That's
types of
correct.
errors, we realize
Correcting, say, correcting, retaining, uh, correctly retaining the null hypothesis and correctly rejecting the null hypothesis. That's the answer, right?
that is not true.
Oh, okay. All right. I stand to be corrected, sir.
I said when we were looking at the null hypothesis, the type of error, you realize that at one point in time, this is what I showed you. And I was telling you that there are two kinds of errors you can make, type 1 and type 2 error. When you make the type 1 error, when you make type 2 error, you saw at the off diagonals here, you make correct decision. That is why I asked the question, when do we make correct decision? You make correct decision when you reject a false null hypothesis. When the null hypothesis is false and you reject it, it's a correct decision you have made.
Oh,
When you fail to
okay.
reject a true null hypothesis, the hypothesis is true and you do not reject it, you correctly fail to reject it. You have make this is when it means that you retain what? A true null hypothesis. So when you fail to reject or you retain a true null hypothesis, you make a good decision. When you reject a false null hypothesis, you make a good decision. These are the two correct decisions you can make.
Thank you. Thank
Okay.
you, sir.
The next question that I was preparing for is this one for this guy. I'm preparing this one. I have prepared this one, for Paga. What's the difference between directional and non-directional hypothesis?
The directional one is the one that there is a difference in a specific direction. The
There's a difference in
non-directional,
a specific direction.
yes,
So give me an example to see that.
like
Example to clarify that.
A is greater than B, or maybe A is less than B. So that one is one.
You have not said anything yet. You have. If I said A is better than B, in what way? In how? What? Please talk in statistical terms and then make very strong, precise arguments about what we are trying to say.
So the probability that A is greater than B.
Please, no, we don't have probability in stating this thing like that. Your null hypothesis, state your null hypothesis and then use it for that example.
Okay, so the probability that A will occur is A, and the probability that
Of a directional hypothesis.
the probability that A will not occur is B.
Directional hypotheses are those hypotheses that shows a specific side or shows a specific kind of directions as to what the claim is going to be like. So in that case, if the claim is about increasing in something, that is it. A typical example is that if I'm making it less than it, if it is the same or less than it, then that becomes what? A non-directional one. Another example of the non-directional one is that the age of females is not the same as the male of the male of females, the age of females is not the same as the age of men, right? It's not the same as the age of males in the class. That means that it might be less than it or it might be more than it. That is a non-directional one. We can also test a hypothesis that the the claim could be that the thing should be at least something. If the claim is at least something, then the alternative will be that the claim will be at most and above or something like that, right? So oftentimes for you to determine whether we have a directional hypothesis or non-directional hypothesis, oftentimes use the alternative to determine that. Take notes again. Use the alternative to determine that. I will also add that anytime we are stating hypothesis, oftentimes stating the null alternative hypothesis is easier. Stating what the alternative hypothesis is sometimes easier than the null hypothesis. Please take notes of that. Let's look at this example. Or do you want to take some 5 minutes break and then come back? Since we are going to close at, you know, 3:30. So maybe let's do it when it is 2:40. Then we reconvene and continue. But when you are away, remember that this is one question that you should be looking out for and try and solve it before you come. So let's reconvene when it is 2:40. Okay. You can take a screenshot and keep it, and then, or maybe let me take a screenshot and post it in the class so that those who want to log out and come back when it is, you know, can do that. But remember, I will surely take attendance, and I've not taken attendance yet.
All right, Doc. Thank you very much.
So for 2:40, we are coming back in. Or
Okay.
you know, Florence, take it and put it in the class speech.
Okay.
Take it and put it in the class speech.
Hello, sir.
Yeah.
Please, I have a question. I don't know if we should return, and I'll ask that question.
Some people have just started logging out. So then go. Let's go and come.
Okay.
Okay.
Okay, sir.
Doc,
Thank
can
you.
you please project it so that I can take it and post it on our class page, please?
But is it not projected?
No.
Hey,
Florence, it is there. Take a look at it.
hey.
Oh, okay. I
Mhm.
can see it
Okay.
at my end
You
here.
the
That's
one who
fine.
can see it. Can you take it and post it? Post it on the page. Just do
Okay.
screenshot and post
Yeah.
it on the page.
Please do it for us
Any
because I
of
can't
you,
see it at my end here, please.
network is bad.
Please,
It
sir,
doesn't
there's example
say
two
in
question. Eh?
notification. Question example two.
Okay, okay.
It's not in a good location. Have you done that? Let me off this thing. I'll give my device some rest when I go and come back. Can you hear me? Okay.
Yes, Doc.
I was presenting to myself and I realized that I might. Okay. So have you gone through this? Somebody should guide us. This one is for guys. This one is guys only. Who is helping us? I can see two Erics. Their mics are on. So can you help us?
Um, Doc, good afternoon once again, Doc.
Afternoon.
I think I want to be brief here, and
Were you the
I
one
have
who
to
wanted to
read.
ask the question? You went.
I want to read the question first before, as you have
Okay.
gathered it, before I can deduce the point from the question. The police chief select a sample of 49 local police officers from a population of officers with a mean physical fitness rating of 72 plus or minus 7.0. That is a mean plus standard deviation on a 100-point physical endurance rating scale. He measures a sample mean physical fitness rating on this scale equal to 74. He conducts a one independent sample Z-test to determine whether physical endurance increase at 0.05 level of significance. 1. A, that is a 1 or A. Set the value of the test statistics in order to
It's the
retain
value of the
or
test statistic.
yes, set the
I read
value of the
very well.
test statistics and order
I'm
to
reading as if
retain.
you are not teaching somebody to read. Hmm?
Yeah,
It's like a man.
not that well, but I have to manage to retain or reject the null hypothesis. The 2 is compute effect size using coherence G, that is the Jacob coherence. Doc, I will answer this question, but first of all, taking the given population mean, that is 72, the sample mean is 74, the population standard deviation is 7.0, and the sample size is 49. So in this case, the formula for the Z-test
You said what
statistics
is 49?
is that what?
You said
The
what is
sample,
49?
the sample size,
Okay.
I mean the sample size, Doc.
Mm-hmm.
I said the sample size is 49.
Mm-hmm.
So by using the Z formula, Z is equals to 74 minus 72 all over 7.0 divided by the standard deviation, that is the 19. So in doing so, when you deduct 72 from 74, it will give you 2. And then when you find the
My brother,
standard,
what are you doing?
I am solving the
Hello.
question, sir. I am solving the question 1.
You
That
see,
is the
read
A.
the question. The first requirement is what? State the value of the test statistic and whether to retain or reject the null hypothesis. What do you do with the first step? Please, you have to go through the standard way of testing a hypothesis. This is a pure hypothesis test question, so you don't start by anywhere you want to start from. The first thing that you would want to do is to, first of all, start with the statement of the hypothesis. Remember, there are 4 steps, and just
Okay.
echo the steps that we go through in testing hypothesis. Let me see if I can have some screen here, right? Let me have
Doc,
my, you hold on. So let me have the first point over here. The first step over here is to state the hypothesis. The hypothesis, right? Thesis. Now, the first hypothesis that we have to state is the null hypothesis. Then we also state the what? Alternative hypothesis. This is the first step you ought to do, because if you look at oh, this thing is gone. The moment you switch between the screen, your whiteboard is gone. Hey, is that how it is? So you see, from the question, you see what the question is suggesting. It says that, you see, it doesn't tell you that go through statistical tests or whatever hypothesis test to be able to solve it. It says that state the value of the statistic and whether to retain or reject the null hypothesis. The first thing, you have not stated any hypothesis. So what hypothesis are you going to reject at the end of the day? Do you get it? So when a
yeah.
question of this nature is given to you, the easiest way is to go through the 4 stages of hypothesis testing. First, state the hypothesis. Now, we are being told that you have a certain mean value of 7.72 and a standard deviation of what? 7 on a 100-point endurance scale. I always say that this 100 you see over here is a nuisance. You not make use of it. But just to let you know that the endurance scale that is being used is 100, right? On a scale of up to what? He's testing something like this. So if physical fitness is 72, that is the population mean. And remember that whenever we are stating hypothesis, we use the population mean, right? Now, he says that whether to retain this or not, but he mentioned something over here. He conduct a 1 sample Z test. In fact, he could have just said that he conduct a 1 sample test, not to mention the Z. You have to know whether you have to use the Z or you have to use the T. Why do you think he's using the Z and not the T? Can somebody tell me? Why the Z, not the T?
The sample size is more than 30.
Exactly. 49 is more than 30, right? Greater than 30. So he's using that particular test to be able to conduct, to determine something. His goal is to determine whether physical endurance increases. Do you get it? He wants to know whether physical endurance increases. So that is his claim he wanted to know. That is why I told you that stating the alternative becomes easier. So in that case, I would have started with the alternative and say that H1 is such that the mu is greater than 72. Just like that.
Okay.
That is the way, that is what I can say. Then I now look at how I state the alternative and use it to state the null hypothesis. That way I can say that my null hypothesis is such that my mu is less or equals to 72. So that 72, so that it can be mutually exclusive. If I don't say less than or equals to it, it will not be mutually exclusive. So you can see how I walk back to be able to state the null hypothesis and the alternative. Another way of stating the same thing is that what I have stated over here. The
Please,
alternative is saying that
if we're sharing the screen, I can't see you.
please,
I want to see the
can you
question.
all, are you all
You can see.
experiencing the same thing?
You can see that.
We can see here.
Okay,
Can you see
I
what
think
I'm
I'm having.
writing and circling, right?
Yes.
Then probably, please, can you check your your internet again so that you can
Repetition
be
of
at
stuff.
speed with us? Yeah. So you can see that if I state the alternative as what, the mu is such that the H1 is such that mu is greater than 72. It means that I'm testing whether there is what, an increase in physical endurance, or you can even say that physical endurance increases. Right? You are making a claim that physical endurance increases. That is a directional hypothesis. That is a directional hypothesis. Then you can now state the alternative that physical endurance does not increases. If it does not increases, it means that it can be the same or it can be reducing, isn't it? It can be stagnant or reducing. Is that not it? Can be stagnant or reducing. That is how physical endurance, you can state the null hypothesis. Then the second step for you to do is what? State your decision rule. Is that not the second step? State the decision rule so that when we are coming down to evaluate the question that whether to retain or reject the null hypothesis, we can use that decision rule to be able to state it. How do we do it? I will now give you this. So the second step, so this is the first step, right? So the second step is, if I will state that if, because he's using Z, right? Z calculated is greater than Z critical. If it is greater than Z critical, reject H naught. Are we on the same page? This is my decision rule. Means that I'm going to be comparing my H naught or H0 for the calculated value and the critical value to make that decision. If you want to go with the confidence interval, you can state the confidence interval rule that if your confidence interval does not run over 0, then the test is significant, for which you reject H naught. Period. You have stated your decision rule. Now the third step is what we are now. The third step is, now you know that the Z calculated, for you to calculate the Z test, or for you to determine the Z calculated, is what? The S bar probably minus what? The mu divided by what? Standard error. Right? Standard error. What is the standard error? Standard error is what? Standard error is equals to the sigma divided by the root of what? N. What is the standard deviation? Is this not 7? So 7 divided by what? The square root of what? 49. That is the N. Is that not it? So it will be 7 divided by 7, which is 1. Is that not it? So it means that your standard error is 1. So if you go back to this formula, you now have what? 72, physical endurance is equal to, so 72 minus 74 divided by what? 1. Is that not it?
Yes.
You see this? That's what you have. And that will give you equals to what? Minus 2. Is that not it? That will be minus 2. So means that your Z calculated is equals to -2. This is your test statistic. This is your calculated value. Then you continue determining your critical value. So what is my Z critical value? How can we get a critical value? We have been given alpha value of what? 5%, isn't it? Alpha value of 5%, isn't it? Means that if I divide this for the two-tailed test, half of it will be 0.5, the other half is 0.5. So it means that this significant level, that 5% is for the two parts. So I have to also divide it by 2. So if I divide the 0.5 by 2, it will be 0.025, isn't it? So I'll subtract 0.025 from what? 0.5. And that will give me what? A proportion of what? 0.475. Is that not it? Now let's go to the Z table and look for this proportion and look for the Z value that is corresponding to this. Everybody, let's open our Z value table. Let's open our Z value table.
It will be 1.645.
1.645. Can we all get the same thing? I have not cross-checked, but it's most likely to be the same or similar.
1.645.
Okay, so it means that the Z critical is what? Plus or minus 1 point what? What is my?
645.
I have now come to this side and was writing, and so that's 1.645. Is that not it? Means that you are done with the third step. Now the last step is what you now do. The last step is this. Take note of what is on this sheet, okay? Because when I move to that place and go and come back, I may not get them again. So the third one, so the third step, which we calculated the Z calculated to be what? The 7 divided by root of, no, sorry, it is 72 minus 74, all divided by 1. So divided by 1 equals to what? -2. This is what we had. And then we have our Z critical. Critical to be what? 1.645. Is that not it? Now, the fourth step is saying that what? We should interpret and conclude on the result. On the results, right? So in this case, what it means is that you now go back to the, this is what we have stated in step 2. Hold on. Hello, dog.
Hello.
Dog, good afternoon.
Hi, how are you? Good afternoon. How are you?
I'm doing well.
I thank God. Very much to meet today. People just was it today?
Yeah, I'm still on it right now.
Oh, yeah. Oh, okay.
Yeah, it's supposed to end at 3:30.
Oh, okay.
So when I finish, I'll call you. All right. Sorry. The course coordinator was the one that just called. So you see that if core Z calculated is greater than the Z critical, we reject H naught, right? Is that not what we stated in the second step? So it means that what you now state is that you see 2 is greater than what? 1.645. Is that not it? So you say that since Z calculated is greater than the Z critical, we reject H naught and fail to reject H1. Have you seen that? We fail to reject H1. Therefore, we conclude that we can now conclude. We conclude that physical endurance increases significantly. Please, do you get that? So all what you are now doing is that you see those stages, what you have already stated before, you are only applying those things to make a decision so that you can now say that, okay, the first step I have what stated a certain hypothesis. The second stage is that I said that if that condition is met, if this condition exists, then this is the decision I will take. So you come to the third step and then now you calculate all these statistics, you get all these values. Then you went back to the second step and see whether that condition is met. Then you apply what existed in the first step and you draw a conclusion based on the topic or the question that you are trying to answer. That is what you do. Please, I hope you get that. So that is how you do you make a conclusion out of this. So in that case, you can now say that hence physical endurance increase. So it means that we are rejecting this and we fail to reject the alternative. In other words, we are retaining the alternative. So when you retain the alternative, you conclude on it. Anything that you fail to reject, you make the conclusion based on it. It indirectly means that you are accepting it, right? So you conclude on that particular hypothesis that you are failing to reject. Please, I hope we are on the same page. That is how we do it. Then the next one is that calculate the effect size. And remember, the effect size is given as what? The, how do you call it? The, oh, I thought that I will get that screen again. The effect size using the coherence G, right? Using the coherence G, this is how it is. So the effect size, right? Effects using the coherence D is just equals to your hypothesize your value minus the hypothesized one divided by the standard deviation. So you can see that what you have there 72 minus 74 divided by 7, right? That will be minus 2 divided by 7. That will give you the coherence D. That is all what you are being asked over here to do. Have you seen that? So of course, you just reduce the other one so that you can be able to see how so that it will not be in the negatives. That is why it's written this way. So please, oh, somebody wanted to say something. Yes.
Yeah, my only challenge I have to do with it is I the population mean.
Mm-hmm.
I think the controversy I have with my mind is the population mean and the sample mean.
Mm-hmm.
I think the sample mean is 74, right? And the
Yes.
population mean is 72.
Oh, I have interchanged
So
them here. Oh, okay.
we have to subtract
Oh,
this
okay.
and
Okay. Yeah, yeah, yeah. I've seen where your confusion is coming from. Oh,
so
I've seen it.
and
I've seen
then
it.
it to be positive.
Yeah, it
And
should
that
be
is it
positive.
will be
Yeah.
positive too. Yes.
Thank you so much for that observation. Rather gone to write the population mean differently. Yeah, yeah. So the population mean, which is the mean. Oh, I'm trying to write it again. Let me on my point. The mu is rather what? 72. And then the S bar is the 74. So that should have given us a positive, right? Of course,
Yes, ma'am.
the mu one is what we have here, which is used in the formulation of the hypothesis, right? So once you have the z value, of course, the z value should have been 74 minus 72 divided by the 7 divided by the square root of 49, which we had to be 2 divided by 1, which is 2. And the coherence D2, it will be 74 minus 72 divided by 7, which is the standard deviation. So maybe let me rewrite it at the top here. So the coherence D 74 so 74 minus 72 divided by 7, which is the standard deviation, right? So that will give them some 0.29 thereabouts. So those are the things. So you can see that it is the question is being asked in a simple term, but you realize that for you to make that determination whether to retain or reject the null, you have to go through the process of hypothesis testing. So I just gave the finalized answers over here. And so what you see over here is basically what we have solved for. Do you get it? So the decision is to reject the null hypothesis. So that is why we also reject the null hypothesis in that case, and then retain the alternative. So you see the coherence D is also given to us as this, and this is the fraction decimal point of view. That is the medium effect size. So one thing that I'll ask you is that when you go and look for the effect size, right, there are ranges of the values. If we range between certain value interval, we call it what? Medium, or the effect size is small, the effect size is medium, and the effect size is large enough, right? The boundaries to that, I don't have the exact figures over here, but one thing you can notice is that 0.29 is a medium effect size. So go and look for the boundaries. I think the book I share with you, you should be able to see that inside the book. It's inside that particular book. I can't really remember exactly the class. I think 0.00 to somewhere 0.2 is low effect size or so. Then from 0.21 somewhere to somewhere
Uh,
0.45 or
please,
so.
please,
So
Doc, can
maybe
I
you
ask?
want to check.
Please, Doc, are you referring to the coherence guidelines?
Yes, in terms of the guidelines as to what the effect
Uh,
sizes are.
I think we learned that the small effect start from the 0.2 and the medium is 0.5 and the large effect will be 0.8 in that effect regard.
No, no. There is a difference between the coherence effect size and what we usually use to determine, let's say, the strength of a correlation analysis.
Okay.
For strength of correlation, sometimes if it is less than 0.3, we call it the correlation is weak. If it
Yes,
is
sir.
between 0.3 to 0.6, we call it
Strong.
medium. Medium.
Medium.
And if it is greater than 0.6, somewhere to 0.99, we call it very strong. But if it is 0.999 going to 1, we call it perfect correlation, right? If it is 0 exactly, we call it there is no correlation, right? So maybe I would have to check for the exact guidelines and be sure of the specific figure when it comes to coherence D. So the coherence D, you can decide to either write the small d and then by not necessarily the coherence D in addition. So take note of that. We
So
also have
Doc,
another,
please, Doc,
all
I
right,
want to understand perfectly. So in conclusion, do you suggest that 0.29 indicate a small
it's
effect
medium.
size? It's
It's
medium.
medium. Yes, that is what
It's
is stated
medium.
here. It's medium effect size. But I
Oh,
wanted to be sure of the guidelines, but this particular one is medium effect size.
okay.
That means we are talking about in excess of about 29%. Yeah. Now, let's look at another example here. Will each of the following increase, decrease, or have no effect on the value of the coherence D? Sample size. Will it decrease when the sample size decrease? Will it affect the how will it affect the coherence D? I'm listening. Now look at this. Coherence D is what? Your value minus what? Divided by standard deviation. Is that
Yes,
not it?
yes, Doc.
And you know also that S minus what? All this one is equals to S minus S bar squared divided by N. So you can see N over here. So if N decreases, what will happen to this expression? N decreases, this whole thing will be high. This whole thing will increase, right? And if this whole thing increases, it means that these whole expressions will fall, which means that when N decreases, coherence D will increase, will also fall. Do you get it?
Say it again, Doc.
You said?
Say it again.
So it means that when N, I'm going through it again. You see, N is at the bottom here, or is at the denominator here. So with the denominator here, when X decreases, when S decreases, it means that this whole thing will increase. If this whole thing increases and you are dividing it by that, that means the denominator has increased. So it means that it will reduce the whole ratio, which is the coherence D. So it means that when sample size decreases, coherence D also what? Coherence D also what? Also decreases. That's all. The second one is the population variance is increased. If the population variance, remember, if this is a population variance, if population variance, oh, okay, because they are talking about sample size, because this is supposed to be for population, right? The standard deviation over here is for population standard deviation. Okay, if this is a population standard deviation, then the sample size do not have any relationship with the coherence D. Take note of this. Let me take this word back. Take note of this. Let me go through it again for you to get this. You see the formula we have here. I just got this. Yes. What you have here is the population standard deviation, right? This is population standard deviation. This value is a hypothesized value, which is the X here. And this is the population mean. The sample size does not really have any direct impact on this. So coherence D is going to be unchanged, whether the sample size is decreased or not. Can we try it with the previous this question? You see what we calculated over here as coherence D, right? Let's decide to reduce the sample size 49. Let's reduce it to 2. In the computation of sample coherence D, it will not affect it because we don't factor in the sample size here. Please, have you seen that? It is not captured here. So it will not have any effect on it because this is a sample size. If it were to be the population size, then the population size would have affected the standard deviation of the population, and that would have influenced the coherence D. But this time around, we are talking about sample size. So sample size has no effect on the coherence D. The second question is saying that population variance is decreased. If the variance is decreased, because look at this, standard deviation. I told you that standard deviation formula is what? If this is the standard deviation, the variance is what? The square of the standard deviation, right? The square of the standard deviation. If the population variance is increasing, if it increases, means that the standard deviation is also increasing, right? Means that the standard deviation is also increasing. So that the standard deviation, once standard deviation increases, you realize that the coherence D is going to fall because the denominator over here is going to be what? Reduce the numerator component over here. So that is going to reduce the what? The coherence D. So when variance increases, population variance increases, coherence D will fall. Sample variance, whether it reduces or increases, it does not have any correlation with, it doesn't influence the effect size, the coherence D effect size, because anything sample does not fit into this formula. Because this figure you see over here is for hypothesized mean. This is the claim you are making, and this is the population variance. So it doesn't have any effect on it. Now, the difference between the sample and the population mean is increasing. So I'm sure that this is to say that when the difference between the hypothesized value and then the population mean is increasing. So if the difference between this one is increasing, means that if you are keeping this one at constant rate, means that the whole expression is going to increase. So if the difference is increasing, then coherence D is also going to increase. It's as simple as that. So the D part, as the difference increases, coherence D is increasing. The C part, as sample size, sample variance increases or reduces, it has no effect on this one. So no effect here. Population variance. When population variance increases, effect size decreases. It's as simple as that. Sample size decreases, it has no effect. No effect on coherence D. On coherence D. Take note of that. Let's look at this second but last one. Will each of the following increase, decrease, or has no effect on the value of the test statistics for the one sample, that one independent sample Z test? The sample size, please. I'll call names to do this one for me. This time round, you see that if one sample Z test, you are talking about X bar minus, say, for example, the mu all over what? Standard error. And you know standard error is also given to you by what? Of the mean of the sample. Is that not it? This is for the sample, right? So this is the test statistics. So if these things happen, would it increase it? Will it decrease or have no effect on the value of the test statistics? So over here also, let me even do slash t, slash the t value, because the t formula and this one formula, they are almost the same thing, right? So let's look at the sample size increases. If sample size increases, what effect do you think will have on it? Be looking at this formula, what do you think will happen? Salifu. 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 I'm listening, Salifu. Hello. Hello. Hey, I can't hear anybody.
Doc, we are here. We are listening to you.
And I'm asking a question. I asked Salifu a question that Salifu, the first one, the sample size increases. Will it increase the test statistics or reduce it, or it will not have any effect on it?
Yeah, I think it will not have any effect on it. That's my take.
Why do you think so? This one is we have moved beyond uh, uh, a second. Salifu, I've just gone through a similar thing with you. I have even put the formula over here, and you don't. You seem to tell me boldly that you think it doesn't have any effect on it when you can see sample size here, my brother. It's okay. Let me say it, and then I know that when you are supposed to go and prepare for exam, you will do it. But we shouldn't rather be learning for exams. Now, look at this. If sample size is represented,
Eh, hello, Doc.
in the test statistic here, the whole denominator. So if the whole denominator also falls, means that the whole numerator would increase once this is held constant. So it means that when sample size increases, the effects, the test statistic is going to what? Increases. It's as simple as that. The next one is population variance decreases. If population variance decreases, population variance cannot, the only population value over here is the mean, right? If the variance increases, it will only pushes the mean depending on the mean will increase, right? It will make the population mean increases widely. It's just like, say, for example, you have something on the number line. You have 5 things, right? Or let me put it this way: the ages of infants or babies or people who attended certain hospital. Some are 2 years, some are 3, some are 2, some are 4, and all of a sudden you saw somebody who is 18 years. You can see that the variations will increase, but the variations, which is the variance increasing, will cause the mean value to increase dramatically. So when the mean value of that population increases dramatically, you see this figure will be increased. If this one increases, holding any other thing constant, it means that the value of the numerator over here will surely increase because the difference between these two is going to be increased, right? But the case now is that when the variance rather is decreased, when the variance of that population decreases, it means that the variations in the mean will be less, which means that this value will be more shrinker, will be smaller, right? So that the whole item over here will also be falling. So in that case, a decrease in the population variance will reduce what? The test statistic. Then the third one over here is the sample variance. Let's look at the sample variance would also influence the sample standard deviation here, isn't it? If the sample variance doubles, means that if it increases by twofold, means that the sample standard deviation can also increases. If it also increases, it means that the whole denominator over here will also increases. If the whole denominator here increases, means that the whole fraction will fall, right? The whole fraction will fall. So when this one, the variance doubled by increasing, right? Increases or doubled, you can see that the test statistics will fall. Then the last one is that the difference between the sample mean and the population mean decreases. So if these differences decreases, it becomes smaller. The whole test statistics is going to fall. So this one, the fall in it will also cause this one to fall. It's as simple as that. These are simple way of understand. So if you're able to do some of these practical things, you see that it's simple, right? Like it help you to really gauge the relationship between these variables you see over here in the formula. That is what it help you to do. Help you to gauge the relationship between these variables, right? Help you to gauge the relationship between these variables. Let's look at the next example and then we close. Natural cork. Those of you who take wine a lot, you know the cork, right? Natural cork bottle is subject to deterioration. Natural one is subject to deterioration, and as a result, wine in such bottle, the natural one, may experience contamination, right? May experience contamination. Now, the there's an article that is called Effect of Bottle Closure Type on Consumers' Preferences of Wine Quality. And remember, there's also this issue with wine that the older the wine, the better, right? The older the wine, the better it is. If the older the wine is and the better it is, and we also know that natural cork in wine bottle is subject to deterioration. That means when the wine is getting older, that means it might also be contaminated. It might be contaminated. So somebody had investigated into this in some years back, 2005, 7, right? He reported that in testing of a commercial Chardonnay is, I'm sure that is a specific brand also of the wine. I don't know. Those of you who are wine takers, you may know these brands very well. 16 of, he said, 16 of the 91 bottles were considered spoiled. So you can see that way you are dealing with proportions. So 16 divided by what? 91. That is the probability the population staff were considered for sport to some extent by the Cork Association characteristics. Does this data provide strong evidence for concluding that more than 15% of all such bottles are contaminated in this way? We should use what? An alpha value equals to what? 10%. We should use an alpha value equals to what? 10%. Let's look at it briefly, how we can solve this particular. So you can see that, of course, the first thing is for you to design or get your what? Your H knots and then what? H1. Let me rush through this fast. H naught and then H1. Do you get it? Now, being that you see that if we have to hypothesize about these 15 and see whether they all are contaminated this way, if they are all contaminated in this way, that means the proportion of this contamination should have been greater than 15%, right? That is why when we come over here, then the proportion, which is P, should be greater than 15%, which means that the proportion of the contaminated bottle is greater than 15%. If you are able to state this null hypothesis, alternative hypothesis, then you can state the null hypothesis in the reverse way. The next thing is, so this is the first step. So the second step is for you to now what? State your decision rule. Decision rule. So you state those things that we stated, that if Z calculated is greater than Z critical, reject H naught. That is full stop. You are done with that. The third step is when you start analyzing the data. So you can see that the proportion over here will be the proportion that is needed to be tested. So this is 17% for the X, or the, how do you call it? Of course, they have already given us a certain proportion for the population. So the mean, the hypothesized value, which is the 15, would have to be tested against the 17. Have you seen that? Would have to be tested against this 17. So using a significant level of 10%, we can perform a one sample what? Proportion Z test. The formula for the test is what? You know this formula already. The upper part, you know it. And you know that for us to calculate the standard deviation of a proportion is what? The probability of the event happening times the probability of the event not happening, right? Divided by n, all square roots of it. And that is what we have at the denominator here. This is equals to our standard error of a proportion. You remember this? We even did this first block. Second block, when we did the introduction, we talked about it briefly. So you know that P is equals to what? And then the Q over here is the same as the P that I'm talking about over here. So you just take note of it because that is the probability of the thing not happening. So if you have the probability of it happening to be 0.1758, then the reverse would have been the probability of it not happening, right? So once you quote this formula, all you have to do is to substitute in your stuff, right? So we have this and you have this. Take note of this. This is wrong. You don't repeat the 15 here. You're supposed to repeat the 1 minus. Do you get it? You're supposed to repeat the 1 minus 0.71758 over there, right? So that you divide it by this 91, which is the n, then you get your value over here. Once we have that, you'll be able to get the test statistics so that you go to the table, find the critical value and compare, and you make the same conclusion as or similar conclusion as we have made over here. So these are some of the things that we are supposed to do. Now, there are a lot of examples of this hypothesis testing in the book I shared with you since last semester, which is the Frederick Gravetta one, the 9th edition. I hope you still have that book in your archives. Please and please, the good news about some of these examples is that after they give you the examples and the exercises, they have solved them at the back of the book. Please take your time, go through each of them. If you don't understand something, I'm always accessible. You can always text or send me a message to the platform. I respond and others would also learn. Other than that, you can also wait when we come to class. We address those questions and then we move on, right? So this is what I have for you for today. Any question? Any question?
Please, yeah, sir, this is Joseph. Please, can you resend the material? Some of us, we don't have it because of one or two issue with our phones. So if you can kindly resend it, I'll be okay with it. And there's this question I had wanted to ask earlier. The one tail and the two tail. Can you elaborate on that a bit for me because it's confusing to me. Thank you.
When they say a test is one tail, what they are simply telling you is that you see this. When the test is telling you one tail, it's just telling you, for example, if it is one tail, you are talking about all this region and the other region. But if it is two tail test, you see that you have a critical value here bounded in between here. So you can see that it's in between. Now, a typical example for you to see whether it's a one tail test or a two tail test, you have your hypothesis like this. Let's say mu is such that mu is not equals to 0. Mu is such that mu is equals to 0. Look at this. This is a two-tailed test because you see over here that mu can actually be less than 0 and mu can actually be what? Greater than 0. That way you are talking about a certain region here, a certain region here that is bounded in between. But if you were to be having H1 to be such that H1 is less than 0, what you are telling me is that the H1 is strictly to one side of the distribution. Do you get it? It's strictly to one side of the distribution.
Okay.
That way
Okay. Very
you are
well.
talking about one filters. I will also again try and send the material, but always take notes, please and please. Imagine that was the end of the class, and you are supposed to, or you are doing something similar. You want to refer to some of these books. Let's have a certain storage media for all the books we are using this semester, all the courses we are doing for this block, all the course materials we are using for this level. I can tell you some of these materials that I'm sharing with you way back 2013 when I was doing this course. Way back 2013, I kept those files. The only thing I do is to just go and look for the updates. When they are updates to the book, look at the additions and then add on to it. Give more examples. That is all. Some of you will grow to get to that point that you will use some of these things. You don't have to necessarily go and be looking for them again. And some of these materials, the funny aspect is that they are being sold at a very good, expensive, or they are quite expensive considering the nature of our currency. They are expensive over here. So if we force and get somebody purchase it and give us a soft copy, let's keep it. Let's keep it. Imagine
Okay, sir.
I
Thank you.
didn't keep my copy right now. This week, go and then look for money and buy another copy. So let's try and have. You can get a hard drive. Do you get it?
Okay.
You might not have the laptop now, but you can get a hard drive and keep all of those things on it. Okay. So I will send it to you guys and then I'll see you then. Is that all the questions?
Okay. I think that would be all for now. Probably next week when we meet.
Yes, I know that the time is going, so you don't want to talk. All right. I'll see you next weekend. Have a nice day. Next week, please revise on this chi-square test.
Okay.
We'll go through it. All right.
Thanks for good delivery.
All right. Florence, course rep, please call me.
All right, though.
Are we having the next class?
Yes, the public sector lecture. So if
It's
you
what?
can join. The public
It's
sector
waiting.
lecture is also.
So this we are just pressing for.
Hello.
Who is on the floor? Please talk. Let's hear you.
The public sector lecture is also waiting. So let us all join that platform. Thank you.